And then you go to design and quick layout. And that's my quick layout. That's my favorite one. You can also get to the chart title, click on all this stuff. Yeah, also, I'll show this again real quick. Got all these options, got so many cool things, it's so nice.
Gary! I was just looking for the sports channel, Gary.
Good morning, everyone. How are we doing? Good to see everyone in the chat. The opening video was paused for some odd reason. So I was like, what's going on? I looked and I was like, wait, that video is not cycling. So it's just like paused on the Stats 201. So, and I want to go in and remake that and put like BAS or something on it, business analytics. So I'll be probably doing that over the weekend. Sorry, my voice is a little bit congested. So hopefully I don't sound too off today and I'm not coughing or anything. I'm fine. Don't worry. Brian's fine. How's everyone doing? How you doing, chat? Say hey to me. Say hey to others. How are we doing? Good morning, Corbin. Good morning. Hey, what's up, Ryan? Good morning to see everybody. Good to see everybody. What is happening? We're going to do a lot of work today. Today's a very, very big day. I asked this, please watch live. One, you get your Streamlab points. So a few people were asking me via email what's the difference between the Mew Bucks and the Streamlab points. When I throw you points, oh my gosh, my voice sounds horrible today. When I throw you points, you email me about those points. Love the shirt. Oh, thank you, Captain America. So I throw you points. Email me those points. There's a cap. I think we said you can get 10 points right now. So you get like 2 5-pointers. And so some people got it here. They were early. Sometimes I throw the points if you're early watching the video. And so be here early. Be ready to start. You only need to be here like 3-4 minutes early because then, we start the video and we're here. So yes, and thank you, Ben. 5 points. That lets me know I'm live. I've streamed live probably 100 times by now, but like one time I didn't actually click the go live button. So I was like, hey everybody, how are we doing? And chat was silent. And I was like, how's everybody doing? And then like another 30 seconds go by and I was like, I'm not live, am I? I look at my things. I'm like, oh, I'm not live. I didn't click the go live button. So it's all the fun of streaming live. It's all that good stuff. Look at all the positivity. Nicole, 5 points right there. All that positivity. Love it in the chat. Saying hey to each other. All those good mornings. Trying to think what else is really big. Your first assignment is due tonight. I would be taking a look at it. Who here has completed the first assignment? Let's see some people in the chat saying that they've completed the first assignment. And now remember, you should by now. Gosh, my voice is so bad today. I was going to record a video last night and then I tried talking out loud and I was like, my voice is horrible. Make sure Streamlabs is on the background. So with Streamlabs, you will be getting your points. I'm just double checking that it's on. CloudBot, you say you're on, but then sometimes at the start of it, good job. People are already doing the first assignment. It's very easy to complete. Love it. Love all those answers. Great job. Remember, just by talking, you're getting these points. People are checking their points. I'm seeing if my points are working. Sometimes it takes like 5 or 10 minutes for points to start up. I still don't understand. I don't know why Streamlabs isn't here at the start. So it's only not worked one time in like 50 streams. So everything, don't worry. If the points are not showing up right now, they will show up because Streamlabs has to wake up, has to drink its coffee. Awesome, Grant. Let's make Grant a mod here too. So the homework assignments due tonight. It takes 5 or 10 minutes. If it's one of your drops, it's not the end of the world, but don't let this one be one of your drops. Don't let it be one of your drops. That's Brian's advice. Don't let this first assignment be one of your drops. But if you miss it, if it gets to 12:02, 12:01, 12, it's due at 11:59, which is the last minute before midnight because I can't set the seconds. I can't do 11:59, 59. And then if I do midnight, then everyone sees it's due the next day. And then I'm like, no, it's due at midnight, but midnight is the morning. So don't wait. Don't wait. Any other questions about class before we get started? Today's going to be a jam-packed day. Today is going to be a jam-packed day. Any other last questions? Ask the questions now. So I bet Streamlabs will start up here at probably about 8:10. It's funny, people will check it like at the moment Streamlabs starts. I'll see like 4 people checking, and then Streamlabs will start at that moment. So I'm sorry that Streamlabs. No, Streamlabs. Oh, wait, literally look. It was between Nicholas and Emily. Streamlabs woke up 5 minutes in. Good morning, Emily. Good morning. Let me get a mod here. So Streamlabs is now awake. Streamlabs drank its coffee. It's doing well now. He's ready to go. I'm going to check my points. I don't know how I get points. I have so little points. So Definitely check your points. Be watching live. Remember, that's how you get points, and that's how you get your bonus in the class. So there you go, Ben. Nice job, Ben. Look at all. Ben just started. Dennis is already at 155. So yes, this is just from one day. So be here live, be interacting. Remember, do exclamation mark points. You get to your points. So if you think about that, what is exclamation mark points? Someone's going to get their full 10 points for the day if someone tells me exclamation mark points is a what within Streamlabs. Just like this. We're going to make Streamlabs go crazy right here. What are these things? I'll take code from Emily right there. That works. It's a code, but I want it more specific. I'll take command from Casey for 10 points. Who else has another one? I'm throwing out for the full 10 points you get today, just for one answer. I would call it almost an algorithm. I'd almost call it that. I would call it a function. Oh, wait, Griffin. Right there, 10 points, Griffin. Yeah, it's definitely a bot. It's definitely a bot. I'll take 10 points from Steven for bot. I like all these unique answers in the chat, but I would call it a function. And what does the function do? It shows you your points. It actually has no arguments. So I'll give you arguments points. Who's first person said arguments? Ben said argument. 10 points, Ben, right there. So it doesn't have any arguments. And you look at the words we're using. My voice sounds so horrible today. I just got to forget it. Got to be like, voice is fine. So we talk about programming. Why do we program? Why does it matter? Oh, I'm currently looking at, let me do something real quick. Do we have a different version for you guys? I didn't think it would matter. I have opened the 474 version of the slides. Just want to make sure I'm doing the exact same version. 2 seconds. Ask those questions in the chat. Because I was teaching 474 yesterday right after you guys' class. And I was like, it's fine. I'll use the same slides because it's same material. We in 474. So if you're freaked out about 474, don't worry. We go through coding again, but we do it a bit faster. Because I had people in 474 saying, I need a refresher. Brian, I need you to go back over how to do this sorts of coding right here. And we do it, but we do it faster. Here we go. There we go. So we got the slides open now. These are your slides. Is it to the right dimensions? I think it is all to the right dimensions. We are good to go. Let me pull back up. These should be these slides you are seeing right here. And does everyone know where the slides are at? Oh, it is the same slides. It's the same slides. I guess we updated and then we kept in. That was easy. So why do we code? Why do we code? Well, so many places. When you look at all the stores out there, all the businesses with data on their customers, is basically trying to understand. One of my favorite stories about Pilot is that Pilot noticed that Red Bull had not been sold for about, I think it was like 3 or 4 hours at one of their gas stations. Now, why would that be? Do you think no one came into the Pilot during a busy time of the day and was buying Red Bull? Everyone's like, we don't need Red Bull anymore. I need a Red Bull. The summer flavor this month is watermelon. Maybe not month. So I'm going to sadly start drinking that every day. Who knows? You'll see me with my watermelon Red Bull. Why would people stop buying Red Bull? Why? Does anyone know? 5-point guesses. They ran out. Yes. Brad right there. Yep. Not an easy place to see in the store. Yes, Sylvia, I'll give you 5 points right there. What actually happened is no one stocked the Red Bull. So they had Red Bull, but no one stocked it. No one, you go to the Red Bull section and the Red Bulls are gone. And maybe it was like a specific flavor, like it was just like regular Red Bull or whatever it was. And that's the thing. Emily, 5 points right there. If you go to Pilot one time and they don't have Red Bull, you'll be like, yeah, whatever. If you go to a second time, or maybe you just go once and they don't have Red Bull and you don't go back, you're like, I need my Red Bull. If I'm, especially you look at truckers and people who take that route a lot, if you were to go there multiple times, like 3 or 4 times, and they didn't have Red Bull, you might just go to a different gas station. You'd be like, well, they don't stock their Red Bull. I go in there to get my Red Bull, and I can't get it. Who here would refuse to drink a Monster over Red Bull or a Rockstar? Like, if you want a Red Bull, you're getting a Red Bull. You're not getting a Rockstar. You're not getting a Monster. You know what I'm talking about. You are Red Bull for life. Sounds weird. Does anyone else know what I'm talking about? Because there's a difference, right? Yeah, you know what I'm talking about. Red Bull's the only way to go. There's a difference. Like I'll have a Monster and I'll be like, it's not the same. It's not the same. I totally agree. Oh, Antonio gets 5 points. He's going against the trend right here. Oh, blueberry. Oh yeah, the blueberry ones. Oh man, they're all so good. Oh man, the Rebel Blue. Yeah, the blueberry. Man, it's so bad. I'll drink them like they're just normal drinks. What is that? Is that it? Oh, those. Yeah, the new ones. The ones in the black cans. What are they? The Rain. Yeah, a lot of people love those. Those are like 0 sugar, aren't they? Yeah, like I know some people who are like, yeah, I drink like 2 of those a day, and I'm like, man, I tried them and they're like all right, but they don't have enough sugar. I'm all about that sugar. I don't get sugar-free Red Bull either. I just love sugar. I'm bad. Sugar's bad for you. Don't drink sugar. So, thanks. No. Tried the lemonade and it was gross. Oh man, we got 300 milligrams caffeine. There you go. It's a drug. I mean, it literally is. So we got all different qualities of data sets right here. So one of the biggest things that we try to do with our data, yeah, the pina colada, I think I tried that one, was pretty good. One of the biggest things we want to do with our data is actually make sure we have good data. So my dad was a statistician. I guess he still is. He's still alive. But when it comes to the companies he's worked for, he would talk about if they collected data and did not collect it properly, and you probably know this, you're just throwing money away. So if you get junk data means junk decisions. And junk decisions are going to make people say, like, why do we pay the stats department? Why do we pay the business analytics department? What's the point? Everything they say is wrong. So there's actually people in the data world called data engineers. And a data engineer, their specific job is to take the data from the customer and get it to the analyst. They don't analyze the data. So these are the people who would work on, like, if you go to Kroger and you have a Kroger Plus card, here's my Kroger Plus card, it's not black for some reason, but they would make sure that when I use my Kroger Plus card, that whatever data we're collecting is created, stored, and then brought to the analyst. So they're just worried about like how we're storing the data, how we're organizing our data, how it's being, just in certain rows and certain columns, what we're recording. So they're going to make sure, and then I'll communicate with them as the analyst who does all the analysis and helps make the decisions on how I need the data collected. So this is a specific job right here, somebody who makes sure that we have good data. And a lot of times, I will say this, one person was in the chat just about a month ago. It's so funny, I don't know if I think I told this yesterday. We were talking about 8451, and one of the students in the class, her brother works there. And she was like, my brother works there. And I was like, oh, it'd be so cool if he joined the chat. And then literally like 5 minutes later, he was in the chat and he was like, hey, someone mentioned me. And I was like, yeah, tell us about 8451. And he was a data engineer. He had a computer science background, because that is a lot more like literally all your job is there is coding. And I hate to say it, he likes his job. I don't know if I would like that job, because that's literally like you're not doing the analysis of data. You're just literally writing code that gets everything, like connecting computers together and connecting the data to people. I like the analysis of data. I like the making decisions from data. I like the what does this mean for the business data, not the let's just write code. Code I use to make things happen. This class is not just all about code, but you are going to learn how to code today. You will know a good bit more how to code. So if you like making decisions, if you like solving problems, if you like puzzles and stuff like that, then this is kind of what's for you, because that's what I see this as. I see it as like, let's solve a puzzle. I'm like, cool. Let's figure out the answers. We got types of data right here. Basically, there's mainly 2 types of data. Who knows the 2 types of data in the chat? 5 points. Would you suggest business science major to be it doesn't hurt. Doesn't hurt. I think it's a good it's computer science is like the in-depth, and then but I would say we give you enough. Like we've had people go on and be just fine with what we give you, but it doesn't hurt. And I would also say things like, and great job in the chat, 5 points right there, Ben, everyone else, and Antonio and Nicholas. Categorical and quantitative, the 2 types of data, or quantitative and qualitative is another name for categorical. But I would also say a lot of stuff in the Haslam College of Business, like supply chain, finance, marketing, accounting. If you have a lot of business skills, like if I was a business analytics major, I might triple major in, I might be like supply. If I was going through UT right now, I'd spend 5 years and become like triple major in business analytics, supply chain, and computer science. And that'd be an insane combo right there. Like you'd have some of our best degrees in the Haslam College of Business and then computer science. And I'm not saying you need computer science, but at that point, you'd have like every, oh, it is, Dennis? That's yours? Are you business analytics and computer science? If so, that's awesome. Like, you just want to look at how your majors complement each other, and supply chain's also awesome. I mean, but once again, let me say this: do what you love. Don't be like, I need this to do this. Be like, I like my undergrad's in psychology, and that really helps me with teaching. Supply chain, BAS, and comps. Ha! I just understand. Well, that's a really good combo, I think. I think that's some of our strongest majors across the whole university. I think, and then throw in a little engineering, and you'll feel like a Renaissance person. You'll have everything. I don't know. Then what else do you need? So like, if you be insanity, you'd be like, well, I can do anything now. Not, I don't know. There's things you can't do, obviously, but do what you love. I really mean that. Don't just be like, Brian said I gotta do this or that. If you like it, do it, and that's what I say. Because if someone told me, Brian, you could make $100,000 grading English papers, I'd be like, no way, no how. They'd be like, but you only have to spend like 20 hours a week grading English papers. I'd be like, 20 hours? They'd be like, actually 40. I'd be like, no, I'm not doing it. So nominal categorical variables. This is how R sees them. You should notice in the background, this is probably the keyword. Everyone write this down right now. Factor. Factor. Write down factor. Watch this. Boo. Here's R. We got R in the background. I made it straight so I could bring up R. You ready? So a factor, if you've watched my videos, so let's do this. Let's go to factor vector. So what we're going to do right here, I'm going to do a trick. You ready? Is this a factor? Here's a trick. That is not a factor. That is numeric. I've tricked you. That is not a factor. It's much harder to get a factor. How about that? Is that a factor? Yes or no? First person who can tell me what this is, breaking the rules, gets 50 points. And all you have to do, it's not, I'll give you 5 points right there, Ben. It's not a factor yet. It is a vector. I'll give you 5 points for vector, Jordan. Tell me what the class of it is. So go ahead. If someone has R, if you have R open right now, you can check this. Tell me what the class of it is. Who knows what the class of it is? If you have R open right now, you can tell me what the class is. You can code it. There's a quicker way to code it. You could just take this right here and do that. You can check the, it's kind of an array. It's like a vector is like an array of data. Griffin, 5 points right there. So vector and arrays are pretty much synonymous words inside of R. My hair's like a green tint around it. Who knows? 50 points first person. I'm breaking the rules. Remember, you only get above 10 points if Brian breaks the rules. Who's going to get it? You can check it. You can go inside R right now. Have R open. This is Brian's check. Do you have R open? All you have to do is write that code. Everyone's like, someone's going to do it before me. But no, go do it. Put it inside of R now. Have R open while we're teaching right here. I've got it up on the screen right here. You just need to write class and then put the thing inside of it. Who knows? I could show the answer so quickly. Oh, wait. A not. Oh, my gosh. Haha. It's broken code is what it is. It's morning. There we go. It's a character, Jordan. I think you're right. Yep. It's character, Jordan. 50 points right there. It's character vector. And sorry, someone should have said it's broken code. I would have given points for broken code. It was looking for object A and object B and object C in the global environment, and it broke on object A. So when I asked it to use A right here, it was actually, the only way this code would work is if I had... We all write broken code. And then let's go down to here. Let's re-grab our old code. and here's this. So this code right here will work now. Why will this code work? In my global environment is A1, B2, C3. So now because those exist in the global environment, that code will work. Does that make sense to everybody? And now this vector right here is numeric. But now when I run this, it's categorical. So let's make this more obvious. Let's call this numeric. Let's go right here and call this character. And we'll explain what characters are in a second. And let's go here. We know what the classes are, so we don't need that. And let's do a factor now. Oh, sorry, misclick. And then we go here and we go factor. And now let's take a look. There we go. That is a categorical variable inside of R. Let's see if everyone understands what we have. When you do code, so this is many of your times first doing code, I ask that you have R open in the background and you try to write down what I'm writing. I will pause on a lot of these screens so you can be listening to me in the background, but I ask that you try to write down what I'm writing just for practice. But here's what you need to do. When you get good at code, you can read everything you code as a sentence. So when you get good at code, you can just read it as a sentence. So who would like me to read one of these lines? Tell me, read line 1, 2, 3, 4, 5. Who wants me to read a certain line as a sentence, as though I'm just talking to someone? Because I should be able to turn my code into something I can just read to someone as a sentence, which is the goal of good code. Read line 3. You got it. Store into a character vector the concatenated vector of the word A and the word B and the word C. So this is the store into. Do everyone see how I said this is store into the character vector? It's going to store into character vector. You kind of have to reverse that one. You could say character vector will have stored into it. That works. Character vector will have stored into it a concatenated vector, which means it's just going to make a vector of the word A, B, and C. Read line 5, please. Tell me the class of what the factor vector is. Tell me the class of what the factor vector is. So when I ask it, it says, well, that's a factor. It says factor vector is a factor. So, and then people said, read line 2. Line 2 is store into numeric vector, or numeric vector will have stored into it a concatenated vector of the object in the global environment A and the object in the global environment B and the object in the global environment C. If you're concatenating these characters, does it become a string or does it stay? So when you concatenate, great question right there, Dennis. All concatenate does is it's like glue. So when you think of concatenate, just think of it as glue. So here's the concatenate function. And then I want you to say this. I want people to write this. Functions use this. Put this in the chat for 5 points. You can get some easy 5 points. Functions use this. That's a big thing. Functions use parentheses. Functions use parentheses. So do you see that class is a function? Nice job right there, Jordan. Jordan, you're at your 10 points right there. Everyone else, Sarah and Mila. There we go. Got it. Just sometimes I overthink it. Mila right there. Excellent job. Yes, functions use parentheses. So we should know that right here. So class is a function. This is a function. What is one other function that you see on the screen right now? 10 points, who sees it? What is one other function you see on the screen? Class is a function. Concatenate is a function. What's another function? Factor. Nice job, Dennis, right there, 10 points. So what we have right here, you know what? I'm making the limit today 20. I'm already breaking the rules. You can get up to 20 points. So what are functions? Think of a function as this. Like if Brian was a function, you could do this. I'm going to pick some. Let's see, Brian. Let's do this. So this is a Brian function in the chat right now. So there you go. Who's gonna do something with the Brian function? You can only ask normal things. Don't go crazy. Who's gonna use the Brian function right here? Look right there. I'm scared. People are like, give 100s to everybody. Oh, wait. Well, that's a pat head function. So the Brian function takes arguments of what Brian will do. The Brian function doesn't have to run. It doesn't have to compute if it chooses not to compute. Do a backflip. I wish I could just like take my image and flip it right now. Give everyone 10,000 points. That function broke. That argument doesn't work, Ben. Sneeze. Look. There we go. Didn't actually sneeze in my hand. Faked it. Clap. There we go. 5 points. All those Brian functions right there. So what you... Oh, heck yeah, we're going to crab rave. You know that's going to happen. 10 points right there, crab rave. You know it. Where's my thing? I need to set it so I can automatically do it on the screen. Oh, that's awesome, Corbin. You know it. So, pat head. There we go. That's how we use the Brian function right there. So, step. I don't know how to step. So, look at what you have. You have a Brian function, and then it takes arguments about what Brian will do. So, the class function, what does the class function do? It takes arguments, and it tells you the class of something. So, the Brian function would be a Brian. 5 points, Emily, right there. Dab on someone right there. Oh, man, it's getting clipped. So, it's not getting clipped. I don't think so. The class function is a function that takes an argument, and that argument is the class of what it'll tell you the class of that. The Brian function is like a function that makes Brian do things. Does that make sense? So what does this function right here? It glues things together. And what arguments does it take? It takes the arguments of what you want to glue together. So these will be glued into a vector. Does that make sense what this function does? And it takes arguments of what you want to glue together. So all of the arguments here are just glue this to this, and it turns it into a vector. Like, it doesn't literally glue it together. Someone's like, where's the glue? And I'm like, it's a vector. It's been put together right there. So you can turn this into a vector, and then you could store it into something. Does everyone understand how I vectorized this with C, and then I stored it into something with the left arrow? And that thing I'm storing it into is X, and now X is literally that thing. If you go and look in the global environment, you can see that X is literally those numbers now. So X is literally those numbers. So what can I do now? I can go summary of X, and it'll give me a summary of X, which is those numbers. Well, let's pause here. Once again, this is 320 where I slow things down, and I want you to know everything going on. There are 4 sections to R right now. Does everyone, who here would say they know every one of these sections and what they do 100%? Or do you want me to review them? What would you like? I know them or review them? I would do a vote, but I think I know what the answer is. I was like, I know what all 4 of those do. I know exactly what every section in there do. Review, Antonio, you got it. Let's review them. Please review them. You got it. And please ask questions if you have them at any time. If you teach these things for a long time, they become common knowledge in your brain. But I'm trying to go as slow as possible today because this is like the first major day of coding. Once again, please be here and please pay attention. Please ask questions. That's why I interact with chat. You guys got it. And you can stream up points. So this section right here, this window, is where you work within your files. So what are your files? Well, generally, they're either R scripts or R markdown files. And R script is just where you do code. So everything inside of here is all code. It'll probably get mad at me. I can make it get mad here, hopefully, or not. That won't run. But usually, I wish you'd give me some error lines on this. But right here, this is where you work within your files in this window. So why is the numeric vector there is no with the letters? Oh, Antonio, great question. So with the numeric vector, so the numeric vector is actually just 1, 2, and 3, but I was using A, B, and C because they were stored to the global environment as numbers. So what is A? A was 1, B was 2, and C was 3. And so I actually made a numeric vector. Like if we go back in time now and we look at this numeric vector right here, the numeric vector is 1, 2, 3 because A, B, and C are 1, 2, 3. But these aren't the words A, B, and C. These are the objects A, B, and C in the global environment that are 1, 2, 3. Does that make sense, Antonio? And Antonio, 10 points, because that can tell us what this is right here. This window right here is the global environment. I mean, it says that, but this is the brain of R. This is like its brain. So you can tell R, you could be like, Brian. You could tell R that, and you do Brian, and it says, is cool. You could be mean here. Go. And there you go. It says, you say, what is Brian? It says, Brian is not cool. So you can do this right here. It just stores this, and you could do things like this. Oh, wait. There we go. Okay, what will this say? What will this say when I run this code? What will this say? So cat right here is how we oftentimes put together words and paste. So this is literally just going to paste this, where I could just use paste, but I like to use cat paste and then put inside of here this. My friend said to me, man, that is so, I guess that needs to be in quotes, like double quotes. That is so not cool. So you see, they said to me, that is so Brian, but what is Brian? Brian in the global environment is not cool. Sorry, Brian. So, but, so you guys get what's going on if you can understand how this code works. Concatenate the code with this. Yes, let me grind them out here. So we have right here, this right here puts everything together and it puts it into like a sentence. You can just use paste. You can just like do paste. And I think pig taste more You can go Brian, comma Darren. You see, it does that right there. So that puts it together. I like cat paste. It just does more options. So you notice paste is a function that takes arguments of what you want to paste together. Does that make sense when we say this right here? Paste together the words Brian and Darren. And this allows us to cat together, which is, this is also concatenate together the pasted words of this right here. The reason I do this is you can also now have the options of concatenate, this version of concatenate right here, and you can also have the options of the paste function. So this gives you the options of both functions when you write it this way. You don't have to write it this way. It's just Dr. Petrie taught me this way, and I do it. I think it's good. But you could just use a paste right here. So interestingly enough, there's another type of paste. Who here can tell me, and I always forget about this one. I want you to look at this right here and look at the codes and tell me the difference between paste and paste 0. So what is the difference between paste and paste 0? Here's paste 0. What's the difference between the space? Yes, Ryan, let's add in 5 points right there. Yes, you're seeing it. And so paste would be like, paste together the words Brian, Darren, and Emily, and you could say with spaces between them. And then paste 0 is paste together Brian, Darren, and Emily with no spaces between them. So you're just telling it what to do. Put these words together with no spaces. What's interesting is there's an additional argument here, sep, and you could go, now look. You can control what separates the words. Paste together the words Brian, Darren, and Emily separated with ... And that's what happened. Always try to read this as a, like, what you're telling the computer to do. The more you do that, I think, Dennis, do you code? I think you do. So Dennis, do you ever try to just read what you're doing and just try to put it into normal words? Like to be like, oh, it's going to do this, this, this. Like the more you can just read it as a sentence, like it's just like, paste together the words Brian, Darren, and Emily separated by ... I have to. You have to. You have to read it just like it's a language. Don't try to think of it as computer code. I mean, it is. But you have to just read it as, line 10 again, paste together the words Brian, Darren, and Emily separated by ... between them. And then that's what you see down below. It's what you asked it to do. So what's up here? This is our working space. This is where we do our work. You can technically do work down here, but this is like where we usually do what I call throwaway work. Like you do something, if I didn't read code, yep. Dennis, 5 points right there. So down here is where you send your work to your terminal. There are more options. Whoops, cancel. Don't even know what's going on there. New R. So here's where you send your code. Now, probably people don't know how to send their code down there. If you have R open right now, if you are on a Mac, I want you to hit Command Enter. If you're on a PC, I want you to hit Control Enter. So if you're on a Mac, I want you to hit Command Enter. So this is Mac. If you're on a PC, I want you to hit Control Enter. This will send the code down to the bottom. And that's where code is evaluated. This is where code is run. So this is where you write out your code so you can just like look at it while you're doing it and make sure it's what you want. And then down here, you can't edit things. Like I can't edit this. I can go back and look at what I did, but I can't edit it. But I can go here and edit anything I did. So this is where you send your code. And so make sure you've tried this. Make sure you've tried hitting Control Enter or Command Enter on a Mac. PC is just Control Enter. Now here's the funny thing. Down here, for 5 points, down here you just need to hit what to run code. If you put code down here, you just need to hit what? Who knows? Just enter. Antonio, 10 points right there. 10 points, yeah, I mean it. So you just hit enter down here. So down here, you just hit just regular old enter. So the whole controller command is what sends it down there. So when you do controller command, nice job, 5 points, everybody. Thank you, everybody, for listening up, because I'll have a lot of, it's fine. I think for a long time, I would hit command enter down here or control enter. Oh, object command not found. Maybe they updated R. Why is it doing that? That's weird. Well, I don't remember doing that before. Maybe now you're not supposed to do that. Do you see this dustpan right here? You've got this dustpan. Whoop, cleaned it up. So if you did a bunch of things, you didn't just, it broke the code, just go right here, and there you go. Pay respect, F in the chat. So what we have right here is is the error because you have command highlighted. Oh my gosh. Sylvia. Oh my gosh. 10 points right there. Thank you so much, F in the chat. I love it. So it was because I actually had that highlighted, and now it's no longer on that line. You're right. Wow, I didn't even notice that. I looked at my keyboard and I was like, I'm on a PC. Why do I have command? Sylvia, I'm giving you 20 points. That you were very carefully watching. I didn't even mean to do that. I was just kind of like showing things, and then I didn't realize. So if you highlight code like this, you'll send that code down there like that. So I forgot I had highlighted something, and I was like, what's going on? Why is it saying a command? What's going on? So we understand this is where we write our code, and this is where we run our code. And then up here is the brain of R. We said this before, but I want to repeat it. This is the brain. It's what it knows. There's other things I could talk about, but just for now, I'm going to call this the brain because it's also where your packages are at. But let's just call it the brain. This is the brain of R. It's what R knows. Right now, R knows Brian is not cool. C is 3. B is 2. A is 1. It knows the factor vector, the numeric vector. It knows X. And then right here is your kind of like help windows and stuff. You got your plots, your packages, your files, all these things. This is like your everything window and your helper window, I call it. It can make your plots. It can tell you how to do things. If you're ever confused about a function, do the following. This will give you the help file on the function. So it'll show you how to do it. There's paste and paste 0. It'll tell you what everything means, but question mark function will tell you that. I just made this mistake. You can't just run the line with cat paste without first running the object creation line. Brian's like, yes, yep. Great job right there, Dennis. 5 points. Yep. And then if you look, they've got a lot of example codes. So whenever you want to take a look at something, you can just take a look at it like this. Here's concatenate and print. And so it goes through and shows you how this all works. Even cat has a separate. I've never used the file, so a connection or a character string, all this stuff right here. So there's a lot of options, and R kind of helps you out with these things. And I'm going to probably have that screen over there. Awesome work. So 2 types. Oh, good. Dennis, 10 points. Dennis, amazing job. Thank you for Dennis, because people are running into errors. Just practice, and you'll hit errors, and that's what we want. We want you to make mistakes. Dennis, how many times has your code not run? Probably more often than it runs, at least if you're me. So when I try to run the paste 0 lines, it only works when I highlight them for some reason. Do this. So I want to make this very clear. When you're running code, I'm trying to oh man, if I could tell you everything I've learned over the time running code. So are you currently in a script or it never worked? Are you currently in a script? Like, is this blue or is it red? Right now, I want you to be in a blue file. R Markdown, yep, that's what I thought. So if you're in an R Markdown file, and this is a really good 5 points, Jordan. If you're in an R Markdown file, when you write code, it needs to be in R chunks, which you can be. And great question right there, Emily and everyone. 5 points, Emily. The difference right here is that a R script is just R code. So let's put a big note up here, and I'll remember to upload these later. So this is only R code. So this is all R code. These things right here are comments. So I'm putting in a comment right there. This our Markdown file, and I'm going to do the following. I'm going to go here like I'm going to use it for notes. You could take notes with this. And I'm going to go here and do May 29th, 2020. And then I'm going to say, these are my notes. And then I'm going to go here and watch very carefully. Don't click wrong spots. I'm going to go here and I'm going to go to Insert R Chunk. You got it, Griffin, 5 points right there. I'm going to go Insert R Chunk. There we go. Does everyone see the change in colors right here? That we have, this is where, and this is like, this is just word code. That's not actually a code. So that's not a code. It's just when you knit it, it'll look different. So these are where your notes are at. This is where your code is at. And the R right here initiates the chunk, but you want to see something even cooler? Let's see. You have to put a space between it right there. And let's go down here. And let's go here to Insert R Chunk. And let's say, and then let's go down here to, you have to leave in that R though. Well, watch this. You get a kind of, what is it, like a, what is it called? I don't know. I can't think of the term. Not a bibliography. But your assignments will be in R Markdown. And don't worry, I send them out to you in R Markdown, so you don't have to create one. But you can also go through your assignment with this. A lot of people don't even know that this exists. I'll show people this in 474, and they'll be like, whoa. Wait, I can click like right here, and it'll bring me to that section of it. I can just use this. Index, yeah. That's what, Sarah, 5 points right there. Table of contents also, Joshua, 5 points. Yeah, I couldn't, for some reason my brain just broke. And so you have this right here. It'll just bring you to these sections. So when you have a longer file, it's like, oh, let me go to such and such section. So you can put headings in here, like with this. You can go here to right there, and now it says it. I think it's, yep, pretty awesome, right? So at least I think it's awesome. Maybe you're like, whatever. But I like it. So this is an R Markdown file. You can't find the C insert. The C insert. Which thing is the C insert? Which thing are you looking for, Emily? Are you talking about command? So on the Mac, you want to go to the bottom left. The command button, I won't be able to raise the keyboard. The command button is on the bottom left of the keyboard, and you want to hit Command Enter. So, or the C insert. Oh, R chunk. Yes, so R chunk. So that, I didn't even know it said C insert. Antonio, 10 points right there. Antonio's right. If you're in a script, you don't have the insert. If you're in a Markdown, you do. Does everyone see how the top right here, the heading changes? So if you're in a script, there's different options up here to run the script, all these different things. If you're in a Markdown, great job, Antonio. Yep, you guys got it for me. What's the significance of using that? So when you're in a, this gets a little bit complicated here. When you're in a Markdown file, the word sections right here, and I encourage you to look at homework 0 because it shows you a lot of this. You can do things like, you can make a word bold. You can make a word italicized. I don't know how to spell italicized. But if you notice right here, this is putting in like the coding for how something will look. So you can make a heading right here with this. So this is a heading. I think you can also do like a bigger heading here. So that'll do like a even bigger heading. We'll knit it right here. Let's take a look. So let's go ahead and knit this. I think, oh wait, will this crash? This won't crash. Let's knit HTML. Oops. Let's just call it random work. call everything random, so I got to call it a new random. So now we can see what it looks like. So does everyone see right here that this created this right here? I don't know why. There's the italicized. There's the bold. This is my code. But this is what I was creating when I was creating everything in the background right here with, if you look at how it looks, if I want it to look like the bigger right here, but you can always edit these things in Word if you want. But I call this, there it is right here. So it didn't do a bigger heading. It just did the regular heading. But this is how you can create all of these things right here. So pretty interesting, pretty fun. You don't have to know all the ins and outs of this. And if I knit it to Word, I think that'll actually be in bold. But this just creates headings right here. I usually use this for like, so, and then this needs no space there. Yes, yep. And so don't worry, that's not actually really coding. It's what I call R markdown code. You're not responsible for that. It's just like, you could do all of that in Word. Like you can do it post, like when you make your file. So no, but good questions. Ask all your questions. That's what we're here to do today, is to like learn the basics of coding. So there's two types of variables, quantitative and categorical. How does R see categorical variables? How does R see categorical variables? How does R see them? You should know this like this. It's a very important thing that we should know. Like probably the most important thing from this slide. It should be like R sees categorical variables as this. You should know this instantaneously. Factors. Nicole, 5 points right there. You're right. Factors. R sees categoricals as factors. So that's how it sees them, as factors. R sees categoricals as factors. There's nominal categorical and ordinal categorical. Nominal just means it has no order to it. Ordinal means it has an order. So a nominal categorical variable would be like the state you were born in. An ordinal categorical variable would be, great job, 5 points everywhere right there. Love all the answers. It shows you're paying attention. Love it. Ordinal would be like stake preference from rare to well done. So we know what nominal and ordinal are. Ordinal has order. Nominal does not. And they're both factors. Yep. And then we have a quantitative variable. Here's the in-depth on it. Quantitative are just real numbers. Quantitative variables are just real numbers. That's all they are. It's like, is somebody's zip code a quantitative variable? Is somebody's zip code quantitative? Is zip code quantitative, yes or no? And I'll tell you the way to know if something's quantitative. 1, it has to be a number. 2, it has to make sense when we say how much is it. Zip codes are not quantitative. Zip codes are a category of people who live within a certain group. So zip codes, when you think about it, you can't say how much is your zip code, or you can't say my zip code is more than yours. I mean, you can, because there's no real, because if it's quantitative, then it has to have like an amount, like how much is your zip code? That doesn't make sense. You'd say, what is your zip code? Like it's a group. And so zip codes are just groups. And they're a little bit ordinal because they go across the US in like an ordinal pattern, where the West Coast has high zip codes and like the Northeast has low zip codes, I think. So there's a bit of an ordinal nature to it. But things like your area code also are not quantitative. Volcard like your Volcard number would be categorical, wouldn't it? It would be an identifier, actually. So Volcard number is an identifier. Because imagine if your friend said to me, my vol number is more than yours. He'd be like, you just got a higher number than me. It just identifies. Does that make sense, Ben? Your vol card number would be an identifier. And that's a special kind of categorical variable. But the amount of money you have on it, yes, right there. Ben, that's what you meant. Your amount of money on your vol card is quantitative. No, don't worry. It's all review. It's all review. Ben, 10 points right there. I want people to give those answers. I want them to just say what they're thinking. Because then that's why I'm here. Because, that's why I teach. You say an answer and I'm like, oh, it's more like this a little bit. So yeah, exactly. Let's do it. We know how data is represented. Here's the biggest thing. We already saw one function today. We saw the following function. We don't need this one. It's just fun. We saw a function right here called class. And let's do class right here on this. Class tells us how R sees this. Now, here's what's very important. The way in which R sees this will control how it does the output. Does everyone see that output? And then look at this output. The way in which R sees the object will control the output. This is the same function, but the object inside of it was numeric, and the object inside of it here was categorical factor. So it changed the way the function worked. Some functions won't even work if you put the wrong object inside of it. So this was a numeric vector put inside of it, literally, and this was a factor vector put inside of it, and it changed the way the summary function worked. So you have to know how R sees what you're putting inside of it. Because if you give it the wrong type of object, it won't work, or it'll do something you don't want it to do. So it's very important we know certain functions, like the function class. So class is how R sees, yep. Alex right there, 5 points, exactly, that's a good note. Be taking notes right here. Maybe shows me the class, how R sees the object. Whatever's inside of there, that's how R sees it. And it just shows you the class, how R sees that object. Just keep taking notes while we go through class, and you'll just learn little bits. It just builds up over time. That's all we do. We just learn little bits as it goes. Little bits. Using R as a calculator, we got this. You can add, subtract, multiply, divide. Do you guys want me to spend another 5-10 minutes on this slide? I think we know this. It's going to get easier here for a moment. It's going to be like, nice and easy. Add, subtract, multiply, divide. So when we do this, a lot of times we'll use a lot of parentheses and stuff. No, I like that right there. So we've got right here that we'll use a lot of division, parentheses. Just make sure your order of operations is correct. R follows the order of operations. Normal stuff. So I'll use crazy amounts of parentheses. You can see the correct ways to write stuff and the wrong ways to write stuff. Like just when you do this right here, this would be 10 divided by 5 minus 3, not 10 over 5 minus 3. So you can see where we don't have the parentheses correct right here. This will immediately do the 10 divided by 5. How do we do a radical sign or radical function? Radical is square root, right? I think, how do you do that? You do that right here. That's the square root radical, right? So, and I'll go back to the other ones, but it was asked right here. But to do the radical, there's a few ways you can raise to the 1/2 power or stuff like that, or you can do square root for square root. But let's say, so an object is when you use that creates an object in the global environment, Alex. Great question, Alex. 5 points right there. So that's how you create an object in the global environment. That defines an object in the global environment. So it says, store this into this. So who here can write a code, 50 points, that finds the cube root of 27 and stores it into X? Try writing the code in the chat, 50 points. These are crazy points for the tough questions that if you can get, you're super following along right now. See if you can do this. If you're watching later, pause the video and try to write a function that stores into, Antonio, nice job right there. Yes, Antonio got it. Nice job. Let's grab Antonio's code. 50 points, Antonio. And that's where you can break the rules. If I say this is a break the rules question, I'll have a few of those. You can only get up to 20 points today. I upped it to 20. We're going to put Antonio's code right here. We're going to evaluate, see if it runs. And then wait. That didn't show me what it was. That didn't show me the answer. But let's do this. You ready? Antonio, we're going to add something to your code. So let's think. What did Brian add to Antonio's code here? What did Brian add to Antonio's code that made it work? Well, it worked before, excuse me. Before, his code just stored to the global environment. And then I output X. And this right here, which you saw me use earlier, I used it up here. You don't have to use the spaces. R just reads through spaces. So spaces are nothing to R. It just says nothing. And so I called the variable, yes, 5 points, Griffin, right there. So you are correct. I just said, now show me X. And Antonio's code worked 100%, and then I just looked at it. So I didn't ask him to show me it. I just said, I want to store it to the global environment. And now if we look at the global environment over here, you can see that X is stored to the global environment. We can also run this line of code right here, which now that removed X, and now I run X and store it to the global environment. So the first line of code right here, store into X the cubed root of 27, and then, because this is an appending, it's going to put 2 lines of code together. So that runs 2 lines of code on 1 line or multiple lines of code, and then show me X. Then just print X to the screen. So this is how you can just print X to the screen. And so it does that. If you were to remove this, it would still just store it to the global environment. In R, what is the difference between printing a variable object and outputting a variable object? You can literally use the function print right here. And I did a lowercase x. Really? I hit caps. That's why I did it. There we go. So print and just doing this right here are basically the same thing. Does R only run one line at a time? If you are using controller command enter, yes. But you could highlight multiple lines like this, and you could run multiple lines like this. So if you notice, I'm running all of these lines right here. So I also could hit Control A, and then I'll run all my lines like that. So you can run multiple lines. Also, if you're inside of a chunk, if you go to an R chunk, this is a very important note. If you go to an R chunk right here, like this one, chunks have the option right here to run a chunk. So you'll use a lot of chunks. Great question right there, Alex. 5 points, Alex. You run the chunk right here by running this, and it runs everything in the chunk. So if you notice, I'm just running the chunk. Look at it from scratch. So that ran everything inside the chunk right there. Does that make sense? So you can run multiple lines, especially if you're putting your code in chunks. You got it. No, great questions. Henry right there, 10 points. Since you already have stored X and R, yes. And then Dennis answered. Dennis, and you guys get the extra, man, just so many points. Sorry. You guys are doing great. 5 points, both of you. Thank you for asking and answering each other's questions as we were answering more questions. If you can't tell, you just have to practice. You just have to do it. You have to write as much code as you can and just see how it works and have it not work. So, will this show you the results in the knitted file? Yep. If we knit the file right here, oops, I closed it. If I knitted the file, it would show me it. So if I knit the file, it'll create all the results. Casey, 5 points, great question. Keep asking those questions. So many great questions today. So this right here is imperative to include the multiplication sign. Yes, this is huge. I've made this mistake. If you do not put a multiply between two things, it won't work. You would think it would know 5 multiplied by this. It actually thinks 5 is a function. So it's saying you're trying to do some sort of non-function thing here, and it breaks. And so you have to put the multiply between them. You have to do it. If you can't see, that's a little multiply right there. So you cannot write it with just the parentheses. A lot of people do that. I've done that. When I say a lot of people, it's me. And I think we talked about this and here. So here we have how to raise stuff. Pretty obvious. If you raise it to the negative power, it does the following. That's how math works. And then right here, we see parentheses are important with exponents. If you're raising stuff to a certain power, like this crazy thing right here, you have to do it with all of this right here. So be very, very careful. Very, very careful. There is the function square root. Someone read this line of code as a sentence. Someone read that as a sentence for 10 points. For 10 points, someone read that as a sentence. Who knows how to read that line as a sentence? How would you talk to the computer? It's like, do this for me. How do you do that? There you go, Alex and Mila right there. Dennis and Ryan and Lexi and Sarah, you guys are on track. I said 20 points max day unless I broke the rules for you. But you guys are all getting up there with those points. Great job. And remember, you are getting your Streamlabs points by talking. So even if you're like, I already got my points, still getting those Streamlabs points. So, which are added on to everything. What does this read? This is absolute value. Find me the absolute value of 10. Well, it's 10. Why'd you ask me that? It's the same thing. Find me the absolute value of negative 3. It's 3. So this just finds you absolute value. I think next we're talking about E. Want to talk about E? There we go. We're talking about log first. So when you do log inside of R cannot be done with ln. So what's interesting is R actually uses 2.71828182845904. This is the log base E of E, and log base E of E is 1. Log base E of E is 1. Because what do you have to raise E to get E? Well, what if you do this? It's that. Because that's log base E of 10. But watch this. What is the second argument here? And so you're hearing some key terminology here. Argument 1 is what do I want the log of? Argument 2, Casey, 5 points right there. Casey knows some stuff. The base. Yep. So that is what you have to raise 2 to. Yep, you got it, Austin. 5 points. The second argument is the base. So this is even beyond the notes. But, oh, look. Hey, thank you, R. R even tells me how to use it. What do I want the log of? And then what do I want the base of? And then, look, it even shows me the default, which Casey put in the chat, is the default base is E, because that's that EXP to 1. If you run it, EXP to 1 is 2.71828, 1828459. Yada, yada, yada. So that right there is E, and that's how we represent E inside of R is EXP, the function EXP. What does base mean again? It's basically like the log base. It's what power you are trying to see, like here, I'll explain. So this function right here, since it's log base 2 of 100, then the question is, what do we have to raise 2 to get 100? And you'd have to raise 2 to this power to get it. And there's some decimal in the background we can't see. There we go. There was a decimal beyond it, but I like it when it says 100. So you have to raise 2 to this power to get 100. So you're asking what, yeah. So that's what the base means of a log. It's like this number is the base you're using to say this power needs to be raised to this to obtain this number. So this reads log base 2 of 100. So you could say, what power do you have to raise 2 to get 100? Or you could do like something crazy like this. And then this is what power do you have to raise 3 to get that? Oh, that's interesting. It's the relationship about, you know, it's going to be weird. If this is 6 something, I'm just going to freak out. Okay, if this is 6 something, I'm going to freak out even more. It's not. It's close. Something interesting there with how numbers work. Just have to look at one more. It's going up by a little bit each time. I want to look at this later. It's just interesting. It's interesting. Numbers are so cool. Like, what if we found a relationship in numbers that no one knew existed? Code. Because I'm not sitting around having to calculate those things. It's just doing it for me. Scientific notation inside of R. Scientific notation is just using E. So when you think about what E is actually used for in R, E is actually just going to be used for like this. You say, well, what is that? That's what it is. You go here and you do this. It's that. So it's how many zeros you have after 1, or it's how many zeros you have before 1, counting the 0, the leading 0. So you have to remember, like, you have to use the 0.00, and then you can count the zeros if you do -3. So nice and easy. We can see how this works, scientific notation. So if you wanted to do like $1 million, you would have to do like this, and you could just write that. You want to do $1 billion, $1 trillion, quadrillion dollars, something like that. And then it'll eventually just say that. But then you could take and divide this by a number, and you'll get the number. So nice and easy, makes numbers a lot easier to write. I use scientific notation sometimes, not that much. Don't worry, you won't see me using it a lot. I forget it exists a lot of times. So there's a lot to remember. So spaces, R reads through every space, so it doesn't matter right here. If I go right here and I put a bunch of spaces, R is just going to read through that and treat the spaces as nothing. So you'll see people write code certain ways. So you'll see I oftentimes put spaces like this between stuff. I have a very structured way to write my code, and you'll create your own kind of structure of writing your own code. So that's all that good stuff right there. These are the easy things. Comments on your codes? Someone put a comment in the chat. Who can put a comment in the chat? Give me some comments in the chat. Show me how you know to write a comment. Write a comment in the chat. Who knows how to write a comment in the chat? Who knows? 5 points. That's not a comment yet. Yes, Mila, you got it. Yep. Nicholas trolling me right there. We got a comment from Sylvia. Comment. All these comment. This is a comment. Yep. That's how we write a comment. You got it. You can use multiple hashtags. Once you hashtag it, it's fine. But I will say this. There is a point to using multiple hashtags. You can do this. So you can use multiple hashtags. So now I've got a comment on this code saying unhashtag if not installed. And so someone can come over here and do this. So sometimes we do multiple comments, but it's a comment within a comment. And so I've done things like this where it says unhashtag if not installed. And that way the person knows, okay, if I don't have this, I'll just go over here and unhashtag this. And you also should notice that the color changes. It goes from green to white. So looking at the colors in your code, it tries to show you, hey, something's going on right here. That's a comment. Semicolons. Semicolons help us append code together. You can if you want. You can if you want. Here, I'll drop it in the chat. We'll be using it shortly enough next week. There it is in the chat. Installed up packages reg class. And then afterwards run I also want to point something out. If you double click, you'll highlight a word. If you triple click, you'll highlight a whole line. So and quadruple click doesn't work. Double click, triple click. So I use that a lot. I'll do double click or I'll do triple click to highlight a line. And if you double click something, you can put it inside of quotes. Oops. You can put it inside of parentheses once you double click it. So you can double click and just put things inside of quotes, parentheses. It'll do that same action on the whole thing. So very important. Do you need to run the library function every time we open our studio? Yes, Brendan, 5 points right there. So once you install it, let me explain this just briefly here. Does it install? Yep. So does it only install it to the active file? So so Brad, great question. 5 points there too. Install.packages. Has anyone ever downloaded a video game before or put a video game on their computer? Has anyone ever put a video game on your computer? Just think about that. Has anyone done that? If so, because I bet one person's done in the chat. If you've done that, you only need to put a video game on your computer one time. But when you load up your computer, does your computer load up with every video game turned on? Does your computer load up with every single video game turned on? No. This is the installing of the video game, which you only do one time. When you want to play the video game, you have to run this line of code. So when you want to play the video game, you have to turn on the video game right here. That'd be nice right there. So you have to select it. You have to turn it on. So when you load up R, it loads up with only your base packages. So you won't have to install this. So you don't have to install it every time. Like that, you just don't do that. It won't do anything horrible, but you'll just be reinstalling your video game. You already have it on your computer. So you have to go here to library. And you see this does nothing now because it's already on. So the library has already been turned on and it ran this the first time. And now it's already on, so it doesn't do anything the second time. The second time it's like, library's already on. Nothing going on here. So we got this right here. We're good to go. We see how to append code. So we look and we can run multiple lines of code on one line. Cool. Why save results? So we can use them. But I will say this, I don't like the equals. Don't like the equals. I like the left arrow. I'll tell you why. It's because the equals is the same thing as a left arrows, but you can also do a right arrow. So I just saved 3 different ways. Also, we'll see that equal will be used for arguments. So you'll see things like, what is that? Take the minus vector here. Cool. And then, good. So if you notice right here, the equal sign, we usually think of equals for arguments. And so this is NA remove. We'll set this to true. Not NBA. Well, we'll do this to show what happens. This gives an NA right here. But now I put another argument in here. And I do NA remove. And now it runs. So we usually think of the equal sign as for arguments and functions. Now, it's not the end of the world. You just will code differently than Brian. So everyone codes differently, but I only use the equal signs in R for arguments and functions. I use the left arrow for saving. So great job on those points there. And so this is how I like to code right here. You might have a different way. It's all right. It's just, I like to keep certain things for certain things. And then it's the equal sign I use just for setting things equal to things in functions. So we have this right here. Let's see. See if there's anything else major. This right here, I can make this look easier on the eyes. Let's go here. And let's put this in right here as X. And then we will just run this. It's the same thing. There we go. Let's take a look at the next thing right here. I think we've seen this a lot today. We should know that how this works right here. Go 930, right? Printing to the screen, just running the vector. Notes about saving. Everything's case sensitive, all that good stuff right there. Representing data values in R. Excellent work. We're doing good here today. We're making great time. So vectors are just things glued together. So we see here we have a numeric vector. Who here can tell me for 5 points what kind of vector this is right here? This is a what kind of vector down here at the bottom of the screen? Who here knows what kind of vector this is? This is creating a what vector? We haven't talked about these much today. Talked about numeric, talked about factor. Character, step one right there. String, I'll take string or a character. Those are both names for it. Character or string. Character or string, kind of synonymous inside of R. This is not a factor yet. We'd have to put it inside of the factor function. No, good points right there. 5 points, Mila, right there. You'd have to turn it into a factor with this right here. So now it's a factor because I wrapped it inside of a factor. So lots going on right there. And so that is a string. Great job. Great following along, everybody. That is a string, and the top is numeric. Here's the same trick I did earlier where hello, it's me is concatenated together into a numeric vector because every object up here is a numeric object. So hello is 4, it's is -2, and me is 100. Concatenating that together turns it into the numeric vector for -2 and 100. Here we go, the types of the different vectors. This is what we saw earlier also. We've got a numeric, we've got a text, which is a string. We won't use characters that much. It's under the modules, under modules. So, yep, go and look for modules. And if you don't see it, tell me and I'll show you where it's at in a moment here. Factors, all the factors right there. You have to put inside of a factor for it to be a factor. Vector types and class function. Once again, we saw this a good bit earlier because I like to future-proof us so we see things multiple times. We just put something inside of class right here and it'll tell us the class of an object. There's more than just it telling us what does concatenate mean? It means to join things together. So you're asking kind of join together a, fast, and cat. And it'll turn it into a vector where things in the vector will have a position. So if I were to concatenate together the numbers like this, it'll turn these into a vector right here. And then I could call this like vector. And now I could do things like this. Who can tell me? That's true. Who can tell me what this will print to the screen? Who can tell me what that'll print to the screen? You are correct, Ben. 5 points, Ben, right there. That'll print 3 to the screen because 3 is the 6th element of the vector now. This is how we get positions. The square brackets, put this in the chat. There's a major note. So let's write this in the chat. For positions, use these. So for positions, use these. What does the C do in line 35? It's concatenating these numbers together. So it's basically gluing these numbers into a vector. So on line 35, I say store into vector a glued together vector of the numbers, blah, 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 blah. And so it's kind of putting them into a vector. It kind of vectorizes them. It turns them into a vector. And so if you notice, we have, once again, I'll put in the chat right here. So this is for functions, and this is for positions. So they're right there. And so we have the arguments inside of a functions are inside of parentheses, and then square brackets are positions. So you got it. And so whenever we want positions, like if I go here and go to X, and I do position 2, it'll say to me 3 also. If I do position 4 inside of X, it'll do that right there. So you can see it right there. Yeah, they do. Brendan, great question. That's if you heard there was a pause. Here they are right here. These are code brackets. These are code brackets. So great job. Let's put it right here. Am I putting it correctly? Yeah. Those are code brackets. So that is where code will be run inside of. So the for loop is a what? The for loop, this for right here is a what? Look at this. This will tell you for is a what? This tells you what for is. For is a what? What is for? For is a what? When do we use parentheses? For is a function, and the for loop will run code. How about this? While loop is a function that runs code. While loop is a function that will then run code. How about the function? Function is a function that runs code and then will save that function inside of something. So you can create your own function. How about there you go. That's how you write a function right there. So that was a little quick. That was a lot. But if you notice, this runs the code. It takes these arguments. Yes. And so you could go right here. We could add something just like that. Won't change it because that's not returned. It's not even saved. So, oh, you could do weird things with this code. You could like make it do things in the background. But that's the code that runs when this function runs. So it's the code that's run inside of there. So it's going to run this code right here because this is the code that's run, and this is the function it's going to use. And these are the arguments inside the function. So listen to the wording very carefully. This is a function. These are arguments inside the function. The function is being saved into this right here, and this is the code that is run inside the function. That is the code brackets right there that we put code inside of. Do you have to define your function at the top of your code, or just I have to define it if I want to use it. So if I'm going to create a user-defined function like this, I have to define it right here. So this is user-defined as in I'm creating it. So when we create a user-defined function, I create it and then I have to run it. If I were to like remove this and then remove add two things, error remove must contain characters. Oh, because I put the parentheses. There we go. I didn't close it. See, now it won't work. But now it will work. So you have to run things in order. So I purposely removed it to then rerun it. I went super advanced here for a moment. If I scared anybody, don't worry. We're nowhere near this kind of coding yet. We're nowhere near it. But if you understand this, if this is like, it kind of makes sense, you're way ahead of the game. Who here feels like this made a tiny bit of sense? Like, I kind of understand what's going on there. That's junk code. If you're like, I kind of understand it, you're way ahead of the game. That would be, you are like 2 weeks ahead. You're midway through the course. So you're midway. Good. If you kind of understand it, that's awesome. If you're like, I don't quite get it. Makes sense so far? So we like to hear. That's what we like to hear. So we got right here. We're creating it and keep asking questions. You just have to keep asking questions. You got to sit down. You got to do some coding. The only way you learn this is you just like try your code. If it breaks, you try it again. You just keep throwing things at the wall. That's what you got to do. Dennis, how many times have you just sat down and tried to make your code work? And I got to say one thing right now also. If you are stuck on your code for more than 5 minutes, email me. Did everyone hear that? If you are stuck on your code for more than 5 minutes, email me and say, Brian, this won't work. Or we need to start using the Discord also. Say, Brian, this won't work. What's going on? Because there's times when you can work on code for hours. It just won't work. I one time had a code I was working on all night and I couldn't get it to work. And then I showed Dr. Petrie and he's like, you got an extra comma there. And I was like, what? And he's like, yeah, just delete that comma. And I was like, oh my God, just one comma. Just have other people look at my code when it doesn't work. Yeah, exactly. You just need a second set of eyes because they'll look at it and they'll like, that. I know. Total Ev in the chat right there. So once again, if your code does not work and you're stuck on it for more than 5 minutes, email me. So what does that mean you need to do for the assignments? And I'll have the first assignment posted for this weekend. I think I'll have it due either Monday. I'm looking at Monday right now for the first assignment being due. Monday or Tuesday. I'll look at where we're at and where I think we'll get to. But your first assignment will either be due Monday or Tuesday. So although you don't have a lot of the tools yet to do the full assignment, should you look at it this weekend? Should you be coding this weekend? What's the answer to that? Because we're getting near the end of class. I want to make sure everybody knows this. Should you be coding? Work on them early. And then here's the thing. If you are stuck on something, email me. Please email me. Don't wait. Never coughing. Don't wait. Don't wait. Don't wait. Conversion of factors. So here's one thing that's really cool. Start soon. Yes. I'm going to have it post. I'll send out a thing later today about it. And start soon. Start soon. If we take our numeric vector, we take a look at it, we can do this. Boom. Now it's a factor. It doesn't look like a factor, but it is. We could check this by going to summary, and it'll no longer give us a numeric summary of it. It'll do a factor summary. So you can convert things using as factor, as numeric, as anything. Look at all these as you have right here. No more as's. As dot all of these things right here. I don't even know what as character dot awk mode is. I don't know. There's so many things right here. There's so many things you can convert between. As complex, that makes it a complex number. As data frame, all of these things you can turn it to dates. As double decimal precision, as integer, all of these things you can do. As logical. So you could do this. You could take a vector of, take this vector right here. I've never tried this. Let's go as logical. And let's see if it does it. Does it do it? It does. We've now converted that numeric vector to logical. So does everyone see here what's going on with the as function? It takes something and then it puts it as this. Does that make sense when you say as this? So we could do this. We could take these right here. We could go to as character, put this inside of here, and it turns those into characters. So what do you notice about characters? Who knows? For 20 points, you can add this to your points. What do you notice about characters? What do you immediately notice about characters, which you should know? What do you notice about difference from numerics? Here's logicals. Here's characters. Yes, Mila, 20 points. You can add that onto your points today. Letting you add on those points. Great job. Has the quotes. Typed out the full thing right there. 10 points right there, Griffin. And there in quotes. Yes, you are right. So characters have quotes. That's what makes them characters. That's how R recognized as the characters. We need to know all these little things. If you can't tell, I want to make sure you know everything that's going on right here. It's very tough because there's a lot to learn, but just these little things. I've got a really great video. Please also, did anyone watch my video series, like the playlist, and feel like they learned some stuff? I hope. And I'm going to try to make some more videos if my voice allows. But I go through all of these functions right here. Ben, awesome. Nicole, yep. So I've got just how to do these different things. Hopefully good. And please give me more video suggestions, ideas. I want to do like really short videos that go over these things that you can just like stop or rewind or look at the code and see what's going on. But I go over all of these quick functions. I do it in 1 minute. I'm probably taking more than 1 minute now. So there's what they are. And I show how each one works. And I put it so they're all just one argument. So here's a little bit of the output of this. All this great stuff. Are my favorite to make and look at? Yes. I need to make a good histogram video. I need to make a good like ggplot histogram. Tables. This will be on your first assignment. I need to make a tables video. I was trying to make it and it just didn't turn out so awesome. So I was like, that's not hot. Will Smith is not happy. So we got here table, length, levels, all this good stuff. Levels tell us the levels of a variable. Plot is, we should update this. Plot will do a bar chart if it's a categorical variable. Plot is a kind of smart function that'll change what it plots. So if you go here, you do plot the numbers 1 through 5, it'll make a line plot of the numbers 1 through 5. It'll make just a dot plot, I should say. But if you go to plot and you go to something like, here we'll go here, library reg class, And then we go to data, survey 10, and we go to survey 10, $ gender. There goes the bar chart. Bar chart. Nice and easy. What we can do is we can take this and we can go here to table. And there's a table. We can also go right here and we can go to, what does the nrow function do? What does nrow function do? Who knows what nrows does? It asks me, it says, tell me the what's of what's. What does nrow do? Number of rows. All that is the number of rows in that data frame. What does ncol do? Number of columns. What does dimension do? Rows and columns. So you can look at what we have right here. We have the number of rows, the number of columns, the dimensions of a data frame. So interestingly enough, what will this return? Who knows what this will return? When I run this line of code, we got 4 more minutes. Don't leave yet. We start on time, we end on time. What does this return? What number will this return when I run it? 20 extra points on your points today. What will this return? You got it, Mila. You are great job. Excellent work. You got it. It returns to me the first element of the dimensions. So it returns to me the first element of the dimensions vector. So which it printed a screen. Does that make sense to everybody? What I returned right here? Do you see how I ran this code right here? And this is the first element. And the second element is this. It's just practice. Don't worry. If you didn't get it, you're like, hopefully you see it and you're like, oh, this is, if I run this line of code, it shows me what's inside of it. And then if I run this, it only returns to me the first element. So it's saying return to me the thing in position 1. So, or no, it's just because this is in position 1, Nick. Does that make sense? This is in position 1, so it returns it right there. Does that make sense? Hopefully it does. Feel free to ask questions if you don't know. Let's see. Get through just a little bit more. Summarizing. We've talked a lot about summary, and we just showed table. So tables and dividing by length, all that good stuff right here. Sequences. I have a really good, let me see, we'll do sequences, rep. We'll do sequences and rep. We won't do which is a little bit longer. So I have a video on sequences and how sequences work. I would highly suggest watching that video. But sequences is the quickest way to write a sequence. If you want to write a certain sequence, like when I wrote my Price is Right numbers, I wrote the following. And that's every number on the Price is Right wheel. The first argument right here is from 5. The second argument right here is 2 to 100. And then the next argument right here is by 5. So that goes from 5 to 100 by 5. I could change this right here to 10. And that's from 5 to 100 by 10. You notice it doesn't even make it. It stops there. So I could change this to 105. And you can notice the small changes right here. For some reason, it spaced the numbers out more. That's interesting. But I guess because it was a 3-digit number, so it's using that spacing. I didn't know it would do that. So now I want to see if I do the following. I'm interested. There we go. Does anyone know what the default for the by argument is? Since I didn't put a by argument in, what was the default for the by argument? And default is a keyword for arguments. 1, you are right there. Brennan, Caroline, 5 points each right there. So this is from 1 to 9. Now, one thing I mentioned in my video, and oops, what did I write? 2 not found. Oh, I did a minus. It's really hard to see that. There we go. 2, 1. Oh, because I did that. And then let's go let's go 2, 1. Oh, no, from 1. From 1 to 9. There we go. And that's the same order. You can change around the orders of these, but you'll be calling them in a non-default way, which is fine. How do you clear the global environment? Great question. Let's end class with that. That's the last question of class. To clear the global environment, you got the dustpan right here, like the dustpan down here. You click the dustpan, you clear your global environment. And now when I ask it to tell me X or use X, it says, what is X? It says there is no X. Great question right there. That's a good way to end class. We'll end class with sequences right here. I would suggest watching my sequences video. It goes over what I've said. And thank you, everyone, for all the questions today. Are you guys feeling good about coding? Do you feel like you have some knowledge, like kind of getting what's going on here? Kind of. We'll be finishing this lecture next class. And we'll look at how do you rename the file where it says untitled one. Go to File, go to Save As, and you just call it like, let's call it May 29th. Oh, wait, let's do this. Wait. BAS 320, and then May 29th. Look at that. There we go. Great question right there. You're welcome, John. Awesome work. So hopefully, I'll open it later today. And so I would start working on it this weekend. I'd start working on it tonight. So I'll open it after class. So stay tuned. Assignment 1 coming up. But lots of good stuff today. We hit on upon a lot of things that kind of even go a little bit beyond the notes. So good job. Make sure you're here. Make sure you're practicing. If you're not here, if you're not practicing, it's going to be a lot harder to learn. If you're not asking questions whenever you're stuck. But so as you know, I will answer all questions. I will tell you all the bits about coding. We got it. You're welcome, Sylvia. Excellent work. It was a really intense Friday. Do not miss Fridays. I know some people are like, oh, I want to sleep in. It's Friday. It's Friday. Can't play that, or else I get in trouble. YouTube would take down the video. I'll hang out here for about 2-3 more minutes, and I'll take a 5-10 minute break between classes. So, I'm just gonna yawn. Even I'm like, man, thank you, Joshua. Man, you know we can do a crab rave. We got you there. Wake up. You too, Brad. Have a great weekend. You too, Sarah. Heck yeah, crab rave. Can people still hear me? Yep. You bet crab rave den class. Oh yeah, do this. I'll tell you next class. If you can, email me that you got the 40 points extra credit too. So when you email me extra credit, be like, also add my 40 points extra credit. I'm saying that now, but email me that you also got the 40 points, and I'll just add it on that way. That way, it makes it easier in my life to not go through old other tutorials. You were talking about the getting started in our playlist. Yes, Alex, watch that. It covers a lot of the topics we talked about today, and it'll be a really good review. And each video is just 1 minute. So it's very, very quick. Even though there's ads on them, you can skip the ads. But if you watch those videos, it'll be a really good review. And I hopefully will put out more this weekend if I feel like my voice is good enough. But I'll hopefully kind of do normal voice. When we do the which function, I think do I sound pretty normal to you guys? Put in my headphones. I don't know if my voice sounds a little off today or not. It does to me in my head. But that's in my head. If I make videos and I don't like you sound fine? Okay, then I might just do videos normally. Then I'll listen back because I can hear small differences in my voice. I'll be like, let's see, I found. Thank you, Alex. But I really want to make a video for each thing we do that it can be used for review. I'd love it if we had a 1 minute video over every topic. That way you could just watch the 1 minute video as like a refresher, or pause it and be like, okay, wait, how do I? No. Yep. So that's my goal. There. We actually made $2 on YouTube. I think it was on Wednesday we made $2. I was like, whoa, we made $2. $2 a day would be $700 a year. So I was like, wow. We had one day in Stats 1 where we made $16. We've made, I think, $47 so far. And you can cash out when you get to 100. So once we get to 100, I want to do the first $100 scholarship. Or not, I guess, scholarship, or I don't know. I just got to make sure with the department and everything, because people want to do scholarships and stuff. So once we get to 100, which we might be able to hit by the end of the summer. I wonder if we could do it for a summer school student. A big thing too is hit on the videos. If you don't want to, you don't have to turn off your ad blocker if you don't want. What you really don't have to. What you can do though is you can hit on it, and you can throw a comment. So comment, subscribe, that whole jazz. It really does help the algorithm. Because I'd really like it if other schools start using our videos too. So how will that happen is if we start appearing in searches. So my goal is not just that UT students use them, My goal is that like other schools and universities start using them or students start finding them and using them. So I'm trying to make really good, short, to the point videos. So if you throw a like on it, that really helps. So because the algorithm will start being like, oh, people like this video. So likes help the videos a lot. So that's I should I should have said at the end of it, if you could just throw a like at the end of this video. I don't know. Like asking for likes can, people don't like that. Thank you, Andrew. Cracking me up right there. I know, but if they get the videos, then we get their money. If we like I need to make more 201 videos and stuff because 201 goes out to like 1,500 students. So if I make 201 videos and half the students watch it, I think we get like a penny a view. So each of those videos we might make like $7, $8 a semester. So if you make, let's say I can make $8 off of one video a semester and I make 50 videos, then that's $400 a semester from the videos I make for 201. Can we get sponsored by Raid? Today's video is sponsored by Raid Shadow Legends. If you guys sign up right now, you'll get a really awesome character in the game that no one else has for this game that is free to play but then costs money. You need a Red Bull sponsor. Yeah, I know. We totally need Red Bull. What about using the profits to put money towards marketing exposure through influencers? Yeah, like well, I think I don't know. It's all these things we could do, and like once again, all this money will go into students or something. It'll go into the betterment of students. Like in some way, it'll be the betterment of students. And I want it to be directly. I'd hate for anyone to be like thinking somehow we didn't spend it for students. So I'll be as transparent. I'll like show my department or like make it public how much we're taking out, and then we'll just give the money to students. I don't know. So how could we? I wonder, like using it for influencers. Like, I don't know. I'm always open to ideas. Take a break here in a moment. Andrew, are you doing well on this Friday? I'm always afraid my neighbors are like hearing me shouting. Doing great. Just woke up. I like it. I'm going to get some coffee. I know I don't have enough time to make coffee. I'm going to take a 5-minute break right here. I'll be right back. I'll see everyone soon for some 474. Here's our 5-minute break. Be back soon. Bye.
just go up here to the top, and you can go to design and quick layout. And that's my quick layout. It's my favorite one. You can also get to the chart title, clicking all this stuff. Yeah, also, I'll show this again real quick. Look at all these options. We got so many cool things. It's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everyone, how are we doing this morning? We got a little SpongeBob to start the morning off. Good morning. We got a Peyton 5 points, Allison 5 points. I was giving some points in the chat right there. It is a good morning. Say hey to someone in the chat. Let's all wake up. Let's wake up here, Stat Nation. Do I have Wacky Wednesdays? It's not Wacky Wednesdays, but I need a little Wacky Wednesdays right now. Oh wait, is he not there? Who's my dude? Oh, it's 20 Tuesdays. I need to... We got Mega Mondays and 20 Tuesdays. There's your wake up right there. Little Mario music. How's everyone doing? A little fun. You guys get to hear the Mario music. I don't get to hear it either. So, like, here you go. Here's your Mario music to wake you up again. It's not 20 Tuesdays, but you get to hear the Mario music. I'm a little bit jealous of that. So, I've got the music I can play in the background. So, good to see everybody. Exactly. Just some study beats, some chill beats. But it is Friday, and this is a very important lecture. Now, one thing I want to point out, I'm going to make sure this is clear, just so everyone knows this. Let's show this real quick. So, hopefully, I'm going to see how many people are watching, and I hope, how many we got? 20? 20 is good. We got more in the class than 20, though. So we should have more watching than 20. But here is yesterday's lecture. So let me switch to full screen right here. And so here is yesterday's lecture going on. And one thing I want to point out is if you go over, it should... Good. It's here. So just so everyone knows, the 320 class is broadcast before our class. Good to see everybody here, Ahmad and everyone. But if you go right here, if you take a look, boom, we were just in class switch. Does everyone understand that you can find out exactly where our lecture begins by going over? You can also go down here to the timestamps, and you could click on our class yesterday right here, and you'll cut to yesterday's opening. So if you're wondering, like, how do I figure out when our class begins? I just want to point this out. You can go to anything right here. You can go to when we started doing the basics in coding yesterday, and you can see. Also, if you want to add comments to the videos, feel free to go down here. It helps the videos in the algorithm. I don't know if anyone will be watching these, but it also helps our channel. Feel free to throw likes on these. Boop, I liked it now. So feel free to like, comment, subscribe, all that jazz. And once again, any money we make will go back into students. So just want you guys to know that if you're liking, if you're commenting, if you're subscribing, it just helps with our algorithm with the students, and which you guys are. And once again, I think we're at like $45 or something. But as soon as we get to $100, I'm going to take the money out. And I just want to give the $100 to a student to say, we gave $100 to a student, and we're just going to keep doing that the more money we make. And hopefully our videos start to catch on, because if other universities start watching them, we become the hub for statistics. Exactly. Thank you to Mod right there. It's the thumbs up are completely free. Just click that thumbs up button. Anytime you're watching a video, like if you're watching the review videos this weekend on how to do stuff in R, just throw a thumbs up on the video. That definitely helps it. And if we get to become very liked videos, all of a sudden then we hit the algorithm. And if more people start watching our video, yes, that'd be awesome. That'd be awesome. Here we are back. So once again, we're pretty much jumping into it. So let me give a few bits of advice. I'll be putting out the first assignment, like the first major assignment this weekend. Who here has done assignment 0 so far? How long did it take you? Who has done assignment 0 and how long did it take you? Who has done assignment 0 and how long did it take you? Like 2 minutes. Exactly. That's how long it should take, a couple minutes. Please, if you have a problem with it, please tell me. Here's what you should do. If you have not done assignment 0, do it right after this class. And if for some reason you have a problem knitting, if something weird happens, tell me. So if there's a problem, if something happens, just tell me, because it should take 1 or 2 minutes. So 2 seconds I had issues. Yeah, exactly. That's the thing. If you have issues knitting, tell me, because there are people who miss assignment 0. Now, if you miss assignment 0, is your world over? Have you failed the class? Can you still get an A? The answer to the first few were no, and the answer to the last one was yes. I threw a lot of questions out there. But I want you to know that it's an easy grade. I want you to get the 100 on it. But if you miss it, don't worry. I'll send you Yes, exactly. Casey, 5 points right there. World's not over. Everything's fine. But if you email me it and you say, Brian, I couldn't submit it and I was trying to knit and my R crashed and everything, I'll say, don't worry. There's 2 drops in the class. And I've had people help me compose this email and be like, what should I write? And we're like, okay, don't worry, there's 2 drops in the class. And then someone emails me and I'm like, don't worry, there's 2 drops in the class. And hopefully they'll remember that. But one thing I want to say is, if you run into any problems, please email me immediately. I was emailing people yesterday. We were hopping on Zoom calls, and we were making sure that everything was working for people. So please email me if it's not working. So, oh my gosh, you're crazy. So I told one of my friends to like watch the stream. And so with this in mind right here, we have right here all of the scientific notation. Are there any questions about what is going on right here? Any questions about the class? Any questions about what you should know? Any questions about the class or what you should know? Who has questions? Is the Analytics Lab 1 all the material we need to know? Analytics Lab 1, and I think I'm going to have to move the date on that. We'll probably be doing it on Monday. So Analytics Lab 1 we'll do on Monday, and I'm thinking if the first assignment will be on Tuesday or Monday. I'll look over the timing of it, but Analytics Lab 1 will have everything we need for assignment 1. Can we write code to predict the winning lottery numbers? I wish we could write code to predict the winning lottery numbers, but nope, we can't. At least I don't know a way to. If you find a way to do that, Andrew, clue me in on that. Clue me in on it if you can find a way to do that. What else is there? If you are stuck on your code for more than 5 minutes, please email me. I think, Andrew, you took 320 with someone else. Did anyone here take 320 with me? So the points that you get capped at daily, yeah. Today I'm going to cap them at 20. Today your points are capped at 20. I'm going to keep throwing out 5 pointers. So I'll keep throwing out 5 points, and your points are capped at 20. So you can get up to 20 points today unless I break the rules. So Hannah, you were in my 320 class. Would I email you guys back if you were stuck on code? Whenever you're stuck on code, which is the answer is probably yes, please email me if you're stuck. If you're stuck on code, email me and say, Brian, I'm stuck on this code. This won't work. Here's my file. And also, let's say this. 1, here's the things you need to do. Let me write down a Word document. Let's go to Word here. So, where's my Word? Okay. So when you are stuck, do this. 1, tell me the problem. 2, three, there's a third thing. Third thing is, send. Here's the biggest thing. Do all of these right here. All of this right here. I love the feel in the chat. Love everyone saying hey to each other. And so do these 3 things when you have a problem. And start early. Start early, and whenever you have a problem, do these 3 things in an email. And once again, please email me with, I think you guys know this, email me with BAS 474 if that's the class you're in, dash your initials, dash title here. If you're in BZAN 522, then email me with that. And so do BZAN 522 and email me with that title, just depending on your title, the class you're in. So very, very important, start your assignments early. Once again, when you were in 320, you're basically going to be doing a first assignment that's very similar to it. A lot of similar questions. It's more of a review. It'll be easier this time, but please start early on this. Please start early. I'm going to put it out today. Please take a look at it and start it today. Okay. So, are we ready to learn how to code some more? Who's ready to learn how to code? I want to see it in the chat right there for 5 points. Who's ready to learn how to code for 5 points? Who's got me? Anybody ready? I need like a SpongeBob, like, I'm ready. I'm ready. We got some people ready to code in the chat right now. I like it for 5 points. Let's go. Let's do this. Me, I'm ready. Toss is ready right here. Everybody, let's learn some code. Cool. Once again, we got an easier yes. Good to see everybody. And be checking your points if you want. You guys are doing really great on those points. So let's take a look right here. And let's get ready to code right here. So here we go. Scientific notation. Nice and easy inside of R. And we'll do some voting on colors right here. I want to make sure we get a color that works for everybody. I'm going to open up a new file for you guys. But we will vote on color schemes, and maybe I need to put out a vote. So we'll put out a vote on what people like best. So everybody's also happy in the chat. Look at all those points. You guys are doing awesome. So we will work on a color scheme that works for everybody and that people like. So I'll send out a vote probably this weekend on the color scheme vote. So make sure to vote in it. Send out pictures of it, and you guys be like, this is the one we want. So we have right here scientific notation. What number is this? Does anyone know for 5 points what number this is? You could cheat. You can go into R and do it. What number is that? Does anyone know? Who knows what number that is? You're right. Oh, it's a graphical error. There you go. 5 points right there. It's 1,000. Then you can change this to e to the -3, and it's that. So we understand the scientific notation right here. Nice and easy. Please tell me if I go too fast. A lot of this stuff is very just review. But please tell me if you're like, wait, what does this do? We see here that R reads through spaces. So I've never tried this. Let me try this. Yeah, did you see the color changed? Didn't like that. Oh, doesn't like that. Doesn't like that. You have to connect those. But what you usually do is you do something like mean, vector, space. So you have to put this thing here. There we go. So the space is right here. It reads through. There are times when you cannot like put a space because, oh, that worked. This will work. But this right here, you have to connect those. So all of these spaces right here are reads through. I've never tried it with other things like that. But when you're using functions and arguments, R reads through the spaces. Spaces are just nothing to R. It's like just nothing to me. So we have R read through the spaces, especially with mathematical stuff. There's things that it doesn't read through. You just have to be careful. So there are some things it doesn't read through. Comments. Put a comment in the chat for 5 points. I know I'm throwing out crazy 5 points today, but put a comment in the chat. Who knows how to put a comment in the chat? Who knows how to put a comment in the chat? Who knows? Put a comment in the chat. Sometimes, yes, right there. Good stuff right there. There's all, it's literally a comment. We have comments in the chat. 5 points, everyone right there. If you notice right here, I'll do this sometimes where I'll put install.packages red class or something like this and then uncomment to install. So this is already commented out because I don't want people to be installing this if they already have it. And please notice the color change because now the code has turned into code rather than a comment. So comments have a specific color to them. So we understand what comments are inside of R. Semicolons. Semicolons are nice and easy. Please take a note if you didn't know it. But you can append together multiple lines of code with a semicolon. So there is 2 lines of code running, very simple lines of code. We could do the mean of 1 through 10 and append to that the standard deviation of 1 through 10. So now we have 2 lines of code running right here on 1 line. So starting off some comment code right there, Adam. So what do we have right here? We have that we can append together 2 lines of code with a semicolon. Semicolons append 2 lines of code together. Now I want to do something off notes here. This is why you should attend lectures and just not only read notes. I want you to know this. Parentheses are used for functions. Square brackets are used for positions. Curly brackets are used for code. These are very important that you understand the difference between parentheses, square brackets, and code brackets. So whenever you see these, the parentheses are going to be for functions, and they will run arguments inside the functions. When you see the square brackets, it's like we have 1 through 10. Let's put inside of here. Now this is just going to make it evaluate like a mathematical thing. It's not really a function. But I do this, and this will return what now? What will that return? It will return 3 numbers. It will return the element in position 3 of the vector. You got it. That's what that returns right there. Third number, yep. So you see how that's used for positions. How about if we do this? We go here to family, and we're just going to create a family vector right here of Brian. We'll do it in order. Darren, Brian, and then we run this, and we say cat, paste, the second child in the family is, and then we go here, and we write family. We do this. What will this write when I run it? What will this print to the screen when I run it? So cat paste is like a way of like, what do you recommend the best way to take notes during the class? Yep, I would try to follow along with what I write, and then also I will post these after class. So I would try to take notes and do it inside of an R file, and I'd try to write as much code as you can during class. Yep. Great job, Casey, right there. 5 points. Casey Payton in the mid. Right here, we see the second child in the family is Brian. And so if you notice, this evaluates right here to the second element of family vector. The second element of family vector. And this is all characters right here that we're evaluating. It's all characters. So this evaluates to the second child in the family is, and then element 2 of the family vector. So it goes to the family vector, and it finds element 2 of the family vector. That's element 2. So, and then you could change it right here. You could do this. And then you could do crazy things. You just like, I don't know, probably the easiest thing to do is go X right here. And then, problem is that the word will change. You go here, and then you just change this to an input. And then I think we'll get an NA here. Yeah, I get an NA. There's no fourth child in my family. NA. The fourth child is missing. Why did it add a... Oh, yeah, great question. So, why did it add it? Which part of the Brian are you talking about right here? So now this is cat paste, and so let me explain some stuff right here. Why do things have quotes around them? Why do things have quotes around them? Why do things have quotes around them? Things have quotes around them because they are strings. They're characters. Strings and characters. 5 points right there. Characters, strings. So it's just a character format. So if you notice line 12 right here, line 12 is in quotes. But then the reason I put this extra thing around it, I put this cat thing around it, is what cat does is cat just literally puts something to the screen and it doesn't have a position in it. So cat literally displays stuff on the screen. That function right here, cat, can be used to join things together and then display them on the screen. So you could write something like cat, and you could go right here. This is what this function does. And you could do Brian, and then was here. Now it's easier to just do, obviously, Brian was here. I mean, what's the fun of doing it that way? But if you notice, it's kind of gluing them together, and then it's just printing them to the screen. Do you know why R uses? Yeah, I don't know why they index at 1 instead of 0. It's a good question, Scott. Scott, if you want to find out more about that and explain, a lot of people have asked me, why does R start its index at 1 instead of 0? Reasons? It's the best I got right now. But no, that's a big question I've been asked multiple times. Nick Brown was the first person who asked me that question. And I'm trying to remember if he found out a lot. I should ask Nick. He's really smart. He's really, really smart. He was asked to go into PhD programs. He's like, I'm going to make money. They made a lot of money. So, but yeah, smart guy. And I bet he might know. But I've always just known R index is at 1 instead of 0. And it might just be they decided that. It might just be as simple as that. Like they're just like, we're just going to index at 1 instead of 0. So Nick's talking right here, or not Nick, Scott's talking right here how we start our indexing of like vectors and everything, all that good stuff. So what we have right here are characters. And this is no longer a character, though. Be careful, though. This is no longer a character. This is no longer a numeric. That's just kind of like a display to the screen. So that's off notes. That's things that just show you what's going on right here. that's just literally displaying 1 to the screen. Because if we go inside this and go class, it's not going to say numeric, I don't think. It says null. I didn't know what it was going to say. That's literally it displaying something to the screen right there. But if you go class of 1, it's going to say numeric. Because 1 is numeric, but this right here is a display to the screen. It has no class. It's just like R just showing something to the screen. But if you go to the paste and you do class of paste, what will this do? What on line 18, what will be the class of line 18? What will be the class of line 18? If we paste something to the screen, what class should there be? I don't think there is. Great question right there. I don't think, Alan, I don't think there is. Because this will show to the screen the character 1. Oh, wait. Huh. Cat. There we go. This will show to the screen the character 1. This will show to the screen the numeric value 1. So, yep, this is, the paste will display a string. Yep, or a character, string, character. String, character, same thing. So, just synonymous words. So, but the next one will have a null class. Oops. The next one has a null class. Oh, and it does that. Oh, because I'll tell you why it does that. Because the cat always displays things to the screen. Because when you run cat, it'll display it to the screen. So when we ran this one, I might have missed it. It might have said 1. It did say 1 before it. I missed it. Because the cat ran inside of here and displayed to the screen, and then we checked it. Pretty crazy, right? That's what's happening. It'll run the cat paste, because it runs the cat, and then it checks the class of it, and then the first element. But do you notice how this has no element position? This is not something, I don't think you can capture it, because it doesn't have an element position. I've kind of worked with it before, but that's not in position 0. It's just, it printed it to the screen, and that's what the cat function does. Cat just prints to the screen. It's really good when you're doing, like if you look at Dr. Petrie's associate function, I think that's how we look at it. So if you look at associate inside of reg class, the way associate works, if we could grab the code, that'd be nice. He's got a lot of like cat here inside of this. So here's his associate, and you can see where he's using cat to show things to the screen. Does that make sense? Our vectors start with 1 because it's more sense mathematical. The only reason I'm going to start at 0 is because of the pointer values involved in older objects-based programs C did. Yeah, so it's cool. It's like we're doing more math-based stuff. We're starting at 1. Dennis, another 50 points. I got to remember that. I got to tell students, thank you so much. And also, I'm giving, who asked that question? Scott, you get 50 for asking that. That's a huge, teaching Brian things, helping Brian give better answers to every question we ask in class. So you can see Dr. Petrie's function, which is almost 1,000 lines. I've written functions that are near 100 lines, but 1,000 lines, woo. And there's special characters he used. I'll go into that later. Okay, we went into a long talk on that on appending code. So we talked about appending code, and we went into a long branch off of that. Here's how you save results. Does everyone know? Show me how we save results in this class. What do we do in this class to save into something? How do we save into something? How do we save into something? How do we left arrow? You got it. You do some left arrow. You just do left arrow. You may not know it. You may not have known it. 5 points right there. All those left arrow answers. You can use equals. I don't like it. I like left arrow. And now someone's got to ask the question, why do you not like using equals, Brian? And, oh, I forgot. We're saving 3 into x, not x into 3. There we go. So that works right there. You can use left arrow, right arrow. You can use equal. You'll just code differently than me, and that's all right. Here's why I don't like using equals. So I'm going to save into x the vector 1 through 10. I'm going to get the mean of x. Let me do this. There we go. I'm going to get the mean of x, and it says NA. So now I have to add in an argument right here. NA.remove equals true. This is good for your assignment. Alt minus? What is that? Oh, is that really? I'll try in a second here. Amid, you are awesome. Amid, 50 points. I love all your answers. Keep them up, because I know if I give Amid 50 points, he's going to keep answering all throughout class. Keep answering, teaching me things. I want you to look at this right here. This is why I don't use, let me try it. Whoa. That is awesome. It's like one less button push, but that helps. So Alt minus, I didn't even know that. I need to know. I love keyboard shortcuts. So we have right here that this equals is being used for a what? When does Brian use equals for in his code? When does Brian use equals? He uses them for these. Brian uses equals when he's using what's in functions. That's when Brian uses his equals. Brian uses equals for I'll take that 5 points for logicals. For arguments for my arguments, Madeline 5 points also. So when I'm using my arguments and I'm setting my arguments equal to something. So I want this argument, and it could be logicals, it could be other things, but like we could do this. We'll be seeing sequence in a second right here. From equals 4. Sure, why not? Oh no, I deleted it. 2 equals 100. So there you go right there. That's why I use it right here, because I don't think you can use a left arrow right here. Apparently you can. They might have updated it, but I like to use the equals when I'm saying this is equal to something in an argument up here. That worked. Didn't expect it to. But we've got the from and we've got the to, and I like to say that they're equal to these things right here, and it makes more sense to me. We're not like saving them to the global environment, and I wonder if, oh look, those saved to I wouldn't want that. Yeah, I wouldn't want this right here. So those saved to my global environment. I don't want to save these to the global environment. I just want to set them within kind of like when I run the function. If I do this right here, it saves them, and then I guess it accesses them. And maybe this is a thing they updated in the more recent versions of R, because I swear it used to not work. So now maybe they save it to the global environment because they run the code inside of here, and then it can use your from and your to. So you guys are awesome, like helping each other out. You weren't able to use, yeah, exactly. That's what I thought. They'll change things because people will run into these errors and they're like, meh, let's just change it. Toss, 20 points right there. I'm throwing out crazy. Today's just crazy Friday points. Crazy points. Who knows what's going on? It's craziness. So let's keep going right here. We can see the arguments. You are correct, because when I learned it, back in my day, you couldn't use that. Now you can. So I like to use the equal sign right there. It's what I do. It's how I code. As long as your code works, you're good. If code works. How do you remove things from the global environment? Great question right there with 20 points also. When you want to remove things from the global environment, you can remove everything from the global environment with the dustpan. So if you have things in the global environment you don't want, you can use the dustpan to remove all of them, or you can use the code RM, whatever you want to remove. So RM stands for remove, and you can remove anything you want using RM. So RM stands for remove. Now, if you're taking notes along with me, put comments out here like removes something from the global environment. It's not how you spell environment. That's how you spell environment. So be taking notes like this. This is what I would suggest is while we're coding today, be taking notes on these things right here, like makes sequence. Pretty easy right there, but just keep taking notes, keep working along, keep writing code. The more code you write along with me, the more practice you get. Who's writing code right now? I want you to take some of you not writing code, open up R. Has anyone written any of the code I've written or is practicing? You just got to be practicing. Just write code along with me. If you're writing the code, you're getting the practice. Me, Andrew, awesome job right there. 5 points, Andrew, right there. Nitin, also 5 points. And Hannah, yes. There we go. Vidrana, 5 points right there. You got it. Anisha, right there, 5 points. Everyone getting 5 points right there. Practice. You have to practice. You have to practice. Everyone who's saying yes gets 5 points. Let's practice some more. That's how you save stuff. Printing to the screen. If we ever say print to the screen, you can just literally type the object name. That's it. Oh, that's so awesome, Andrew. That's so awesome. That's the way to do it. Notes about saving. Case sensitive. Yeah, you can't use, some punctuation is allowed, but there's things that aren't allowed. Cool. Representing data vectors in R. Woo! So once again, please ask for more videos if you want them. I'm trying to make a whole list of videos that people can watch. And once again, if you can use ad block, I really don't care if you use ad block. I would care more that you watch the videos. I do put the ads on them. If you got ad block, cool. Don't worry. You don't have to turn off ad block. Like literally, don't turn off ad block. Just watch the videos. I care more that you watch the videos, and that way you get the knowledge, because I'm trying to put out concentrated knowledge. And then my goal is that they eventually take off. And if you like the video and you watch it and you maybe throw a comment underneath it, that's going to probably help more than the ad block. Also, you're getting more knowledge then. So, and it doesn't take but a half second to like it. So feel free. Everyone have an ad block on. I don't care about that. I care more that you watch the videos and you actually learn from it. Truthfully, I really do. We'll do the scholarship thing. It'll eventually happen because I want the videos to take off. And that'll happen when other people start watching them too. So vectors. Vectors inside of R are just things that have been put together in order. So we're just going to have things in a vector. So if you notice right here, this vector is a numeric vector, and this vector is a character vector. Oh my gosh. Amid, you are the man. Let me grab that code, Amid. I'm going to put this in our notes. Man, you guys are good. I need to remember all these codes too. Like, I'm putting it here for my own reference. So this removes the whole list equals, and then what does the code ls do again? ls is list objects. Returns a vector of character stream given the names. So it's like, and it's like open vector or open on it. So it's doing like everything. So it's like removing everything. So we could put in here an X and a Y. So you could have in your code, clear the global environment. So there we go. There we go. Clears global environment. We got it in our notes. Awesome stuff. So there's just remove equals list equals this. So you could probably admit, I'm betting, I'll bet you 20, I'll give you the 20 points. I'm betting this works. You ready? Let's run this line of code right here. Dang it, you have to put the list. It's not the first argument of remove. If it was the first argument, yeah, you see, it's what do you want to remove and then the list. So if list was the first argument, we wouldn't need it, and that's how you have to call the name of it. If it's an argument that comes after it, so we had to call it. But if it was the first argument, we could have done it by default. Is that true for all functions? The ordering, the way it works right here, if you notice when I go to sequence, which we'll be talking about literally in seconds, when I go to sequence, I don't have to put in from 4 to 100. I can go to sequence and put in 4, 100, and that'll do from 4 to 100, just like this line of code here, because the default order for sequence is from to by. So I know that the default order here for sequence is from this to this by this. So and the by usually defaults to about 1 when you solve that formula. But since I know the order for the sequence is from to by, I don't have to put in from and to. So if you see right here, these lines of code do the same thing, but don't worry, there's graphical error. They do the same thing because I use the default order. So I thought for a moment, and Amid definitely got the 20 points there, that this was the default order and I could run it, but it wants, can I put in a blank? No, it's got to call it as list. So that way it identifies that is the argument list. So I was hoping we could make it even shorter. I was like, oh, that'd be so cool, but it's not the first argument, so didn't work. Wasn't the default order. Here we are with some vectors being created. And seriously, this is, once again, please notice what we're doing. Whenever you have code, you just try things. You just throw something against the wall and you see if it works. And then you check to see why it didn't work. How do you add in by 1.5? Okay, so good question, Alan. Let's talk about that real quick. So this is going to do something very interesting. So that right there does not do a sequence from 4 to 10. And I'm trying to think about why it did what it did. So if you want to do a sequence from 4 to 10, you could do it just by doing this right here. You could do a sequence from 4 to 10 just with this line of code. But if you want to do a sequence from 4 to 10 by 1.5, there. And if you want to go all the way to 100 to do this. So the first argument inside of here is the from, to, and then by. And you could call them by names. You could go here and then go by. And it'll do the same thing. But you don't want to put in here a vector, because I don't quite understand. Because one, this just doesn't make. We'll see what 100 does. So I don't. That gives 100 numbers starting at 1. I don't know why it did what it did, but that's what it does. And I'd have to like evaluate. And this gives like the first 7 numbers. So like what I thought it was doing. Let's see. That I thought that would break, but then I thought it might be doing this. So it just did. Whoops, I didn't do the 5. Yeah, I don't. This right here is not how the code's supposed to be used, and I don't quite understand how the code is evaluating to that. So I don't know. I just don't know why it evaluates to that. That's not how we would use it. If we want to do a sequence from 4 to 10 really quick, we can do that, or we can do the extra extended version. But yeah, that's a good question. That's a riddle that I have not unraveled. Why that code is doing that? Because it's not how we use the function. We don't put a vector inside of there. We say here's where we want to go from, here's where we want to go to, and here's where we want to go by. So and then there's the length argument too. So we have right here the different vectors. We see the numeric vectors. We see the string vectors. Now here's where people get tricked. What kind of vector is this right here? Let's grab the code. What kind of vector is this? What kind of vector is this on line 36? What kind of vector is that? We'll find out in just one moment. You got it, Toss. 5 points right there. It's numeric. Because these are now objects saved to the global environment. Listen carefully. These are objects. Hello is an object saved to the global environment. It's is an object. You can see them up here. And then me is an object saved to the global environment. So these are now getting called. They're not words. If they were words, they'd be in what? If they were words, they'd be in quotes. So the key difference right there is that that's a character vector, where before it was a numeric vector because these are objects saved to the global environment. How about this? What kind of vector is it now? Sure. What kind of vector is it now? Now, on line 36, that's also a what? Yep. Nitten, 5 points right there. Character vector, and I'm just hitting random buttons. It's a character vector. And once again, you can clear your stuff like that so we can just see it a little bit better. But it's a character vector because these are now saved to the global environment as characters. So does that make sense right there? These are now saved to the global environment as characters. And then when we call them, can you call a character vector a string? Yeah, I think they're called identical names between it in R. We call them strings or characters, just interchangeable names. So it's a character or string vector. Yep, great question right there. Great answer. I give the answer. Sometimes I just say something like, what did I just say? Vectors, different types of vectors right here. An important thing, also, can't you do the individual letters without use quotes? It will be numeric again. If we do the individual letters without the quotes, well, I don't think we have something saved as A, though. So I think it's going to say object A not found, yeah. So if it's numeric, it's actual real numbers. So, and we could save A to the global environment. And now this will run, but this will still be character because the rest of it's character. So it'll force the class character on it because part of it's character. So if we look at it, 5 was turned into a character there. So 5 is A, and the object A is 5. So you have to like backtrace. You have to be like, this is like bad code right now, I would say. So A is saved into hello, 5 is A, and then when we concatenate this into a vector, then it becomes the words or characters or strings, whatever you want to call it, 5BC. So if I was talking to someone who didn't know code, I would just say these are words. I would just say like, they're just words that are like in a book. So they're just that, but their characters are strings. So just knowing how to like communicate it. Good questions. We've got right here a factor. A factor is a categorical variable. Factors have levels. Please know this. Factors are categorical variables inside of R. Factors are categorical variables inside R. I can't make that clear enough. You should know this. 5 points. Factors are categorical variables. Start writing in the chat for 5 points. You need to know this. If you do not know factors or categorical variables, dun dun dun. Make sure I put everything in here. Who's got it? Everyone's gotten it. Good. Be practicing. You should know factors. It's like instantaneous. I know some of you are like, I know that. Just anyways, you got it. You got it. So once you know it, you know it. Once you know it, you know it. You'll be like, oh yeah, it's a, there you go. It's a factor. It's a categorical variable. Nice job right there. 5 points, everyone right there. Factors are categorical variables. You can even run levels on it. And you see the levels. What will this return here? What will this code return here? What will this code return here? 10 points first person. We'll return the second element of the levels vector. Boom, Toss, you're right. Mail, you got it. Nice job, Toss. Everyone else, 5 points. Great job following along, knowing how to code. You should often realize what the code is going to display before you run it. If you kind of know what it's going to display and you can read it, you're good. You got it. Vector types and class function. So the class function shows us the class of something. Pretty obvious. I've been running that a good bit today. We just go here to class of something. And we just put something inside of it like A. And A is 5 right now. So A is numeric because it just checked that. So it'll tell you the class of it. And class is very important because that's how R sees the object. So you need to know how R is using it, and the class will do that right here. So very, very important. It's possible to change between different data types. So I want to point out there's a lot here on these pages about changing stuff. But one thing, I've got a video on this. When you change, I think it is this. If you go here and you make a vector, and let's do this. Let's make a numeric vector. I think I got it. So we're going to go and do this. And then I go here to vector, and I go factor. So it did that. And then is it, I need to go back. Try to remember how to break it. There's ways you can break this. And we need to take, if we alphabetize, now it's still got the numbers. If we go character, oh, that'll break it. So if we go as.character, there we go. And then let's do this. Let's take that and go as.factor. There, well, we still have it. Oh. Trying to remember how to break it. I can't break it today. Trying to make it do the things I don't want it to do. No, that's it. I know what it is. Here we go. We're going to take a factor. Yes. So we're going to do this. We're going to store a vector. And we're going to go factor around it. And we're going to go 1, 5, 2, 100, 2, 5, 3, 2, 1. Cool. Then we are going to take this factor. And let's go here. And let's go as numeric. That's what I wanted. What did it do to my factor when I made it numeric? What did it do to my factor when I made it numeric? And watch this. We're going to store that into vector. And then we're going to turn it back. So I'm going to turn it back to a factor now. But now let's look at it. So I want you to watch what happens here. I'm going to clear the bottom console and I'm going to run all the code. So we're going to look at all the code and see the error Brian made right here with this stuff. Okay. Ah, shoot. We should look at it after each thing. So I think some people might be right in the chat. I'll show it. This will hopefully show it really well here. This is a common error people have. So let me clear the bottom console and let's run the code. There we go. So I started off with a factor right here, as though these are reported as factors. Then I changed, oh my gosh. Then I changed it to numeric. So now it's numbers. And then I went back to a factor, but look at my original data, it's changed. So when I went from factor to numeric back to factor, it no longer retained the levels of the factor that were original. Does everyone see it originally had these levels, and now it has these levels? When you go from a factor to numeric, take this huge note down. When you go from a factor to numeric, it'll put them in alphabetical order. We can confirm this by doing something like A, C, B. So if I run this right here and turn this into numeric, all of a sudden it'll become 1, 3, 2. And then when I save it back as a factor, it won't change back. It changed the levels. It alphabetized them. So you have to be careful. You can destroy your data. You can, you start off with A, C, B, then you turn it to numeric, and it becomes 1, 3, 2 because it alphabetizes them. So even if you were to put in Z here, well, we'll put in a Z here. That's going to be 4. My gosh. Now Z will be 5. So Z is now 5 because it is the 5th one right there. It is the 5th level right there. Don't want to be congested. No fun. Does that make sense to everybody what's going on right here? This is a big mistake people oftentimes make when they're changing back between different things. So it's very, very common, but I hope that explains in good detail right there. So what do we have right here? We have 12 easy functions that you can do very, very quickly inside of R. These are 12 very, very quick and easy functions, and I have a video going over them. Check out the video. Pretty easy. You just put something in summary, and you get the summary. You put length, you get the length. You put in sum, you get the sum, all that good stuff. Summarizing numeric vectors, all this good stuff. I want to point this out, though. NA equals true. What does NA stand for? We should know instantaneously in this class what NA stands for. What does NA mean? That the value is what, wherever NA is at. What does NA mean? NA stands for what? When I create a vector, if I go here and I create a vector like this, what does the NA mean? What does the NAs mean? Kind of. It kind of does mean that. It kind of means not available. It means like missing. It's missingness. The best way to describe it is missingness, as though whatever was there is missing or empty. I like empty right there. 5 points right there, Adam, for empty. I like that. And everyone else, 5 points for answering. Just keep answering questions, keep interacting. It basically means it's empty or missing. So when you run this right here, you can see it has NAs. Now those are not like NA words. Those are NA literal missingness. So if you go to position 4, it's literally missing. If you do mean of this vector now, it won't run because of the missingness. You have to add in the extra argument, NA remove equals true, and then it runs right there. Very, very important. And Dr. Petrie's got to update his book about... See, wait, let me try this. Boom. Take that. Didn't work. Didn't work when I used the left arrow. There we go. Now it works. So, null and missingness, like I usually think of null as nulling something out. So I'll show you how I use nulls. So if you go here to survey 10 and you look at something like weight, and there's the weight vector. If I do NA, what it'll do is it'll overwrite all of these with NA. So it'll overwrite everything survey 10 weight with NA. So now everything in there is NA. Like it overwrote everything in there with missingness, but then null is more like deleting stuff. So null is more like it's been deleted. So if I go here to null, and you see it changes colors right now, and it's a special character, it's a special type thing we use. So when I go here to null, watch over here on the far left where there's 20 variables, and now there's 19. So now that no longer exists. It's been nulled out. And that's oftentimes when I use null right there. Null means there's just like, it's not that it's missing, it's that it's like, it's like it doesn't even exist. So I know that sounds weird, and it's weird to think how computers have to see things. Like, you wouldn't say position 4 in this vector doesn't even exist. You would say there's a missing value in position 4. Does that make sense? The value in position 4 is missing. But the survey weight now in this data frame doesn't even exist. And probably, if I were to run something else like this right here and just do that, it would say null also. So it's saying this doesn't even exist. There's just doesn't there. If we have a data frame with missing empty fields, it's better to change. Yeah, totally. I'm in. Yeah, put NAs because that just means the value there is missing. So you would put in NAs, but you'll notice that the program will do this for you. If you look at it, if there is nothing in there, it puts in the NAs by default. So if you import an Excel sheet and the Excel sheet has missing values, like if you don't have something in that cell, it'll put NA in that cell for you. You don't actually have to write NA in there. And be careful, if you write NA, it might treat NA as the word. This is totally different right here. This right here is not a missing value. This is the word NA. So I would not put NA in an Excel sheet. I would just leave it blank. And then R knows if it's blank, it's NA. So R will bring that in as an NA, not as an NA word, but as an NA. Yep. No, great questions. Exactly, Nitin, 20 points Nitin. That's a great way to explain it. Like, NA is an empty chair, and then null is like, that chair doesn't even exist. Or you're like, well, what's in the chair? You're like, what chair are you talking about? So, like, we put values in certain positions. So when you null something out, you destroy it, you make it not exist. Oh, wait, we need that still. Still our notes. But I'll change this back to the NA here, because this will change the type of vector to a character vector. So the coloring will always help you out, but great questions. And it's really through your guys' questions that I, try to expand my knowledge, because you guys ask really good questions, especially in the 474 class. It's like, well, why is it this? What does this do? Here we go. All this good stuff. We got tables right here. Tables and bar charts and all this good stuff. I might make a video on tables if my voice is doing well enough. Come on, voice, you got this. But tables just makes a table of a variable. All it does. We go here to table. We go here to survey 10 gender. Boom. We got it. We get the graphics error. There we go. Where can we find this video for the 12 functions? It is, I'll post it in the chat real quick. Let me post the video in the chat. Video in the chat. Watch these after class. I'm going to post the playlist that I just made. And so watch this video playlist after class. Here, I'll start you off with the Intro to R playlist. And watch this playlist after class. So that playlist right there, watch after class. Maybe I'll send a reminder. It's a really good review of like a lot of things we're talking about today. And I go through every function in 1 minute. If you're stuck on something or if something's not explained to you well enough, just tell me and we'll go over it more in depth. That's what we do. What does this second function do right here? What the heck does this function do? This function I'm highlighting for the mere moment. I'm going to change it in a moment. But what does that function do right there? What does that function do? The number of rows. That's all it is. 5 points in mid right there. You are right. That is the number of rows. So that turns it into a frequency table. Watch this. Now it's percentages. Watch this. So my first, oh, and then we need, nope. Good. Now it's rounded. Look at how easily we can turn something from, let's look at the steps, from a table to a frequency table to the percentages to the rounded. Just watch the steps. Like, slow down the video if you need. Look here, at the bottom of the code, we have a table, or excuse me, a frequency table, relative frequency table, percentages, and then rounded percentages. Nice and easy. Just wrapping our code up, just expanding upon the code we have. Table, relative frequency table, percentages in a relative frequency table, and then we just change it to this. So this is the thing, is like, whenever we're doing work in 201 and you have to round stuff, I'm like, I don't want to round it. I'll just let my Pearson do it. I could, I mean, I'll let R do it. I could just ask it to round it to 3 digits. There we go. I don't need to think. I don't need to, like, I know how to round stuff. I'll do it if it really wants me to. We have number of rows, number of columns. We have dimensions. Who here can tell me what this code will produce for 20 points? Who knows? You can add this 20 points onto your cap of 20 points. I'll let you do that. We break the rules every once in a while, but who knows what this will produce code-wise? Following along, you'd be like, boom, I know what that is. Who knows what this would produce code-wise? You got it right there, Jordan. Great job. It is 19. 5 points, everyone else. 20 points, Jordan. You can break the rules and add that to your 20 right there. Number of columns, exactly a mid. Great answer right there. List the second element of what we produced. Yes, Casey, you guys are getting it. These are amazing answers. You guys are on track. Like, you are understanding every bit of this. And here's our goal. If you understand every bit of what we're doing each day, and don't worry if you don't, we're doing a lot, but if you're understanding each bit of this, it gets to be one of those classes where by the end you're like, well, I just followed the whole class and then I got an A. That wasn't so bad. So keep following along, keep practicing, keep doing the work. It just takes practice. We see right here how to make sequences. We've covered this a good bit today, so I'm going to go a little quickly right here. But sequences has the arguments from, to, and by. One argument I did not mention so far today is the length argument. So you can do a sequence from 1 to 100 with a length of 10. The length, and you can just use length. It does like a partial match. Length of 10 will produce, wait, did I do a minus? I did that earlier today. So the length produces 10 elements right there. It's the length of the sequence you are producing. This is a sequence that is 10 elements long right here. It is a sequence that is 10 elements long. So that is that. We have excellent stuff right there. Go away video. And let's take a look. Just tons and tons of stuff you can do sequence. Tons of stuff. We have here rep. What do you think rep does? Who knows what rep does? Just take a wild guess. What does it do? 5 points. What does rep do? Rep is actually really valuable because what you can do is I'll make loot boxes. I need to do this in the next class. Does anyone here ever buy loot boxes? If you buy loot boxes, like online. So there's our winners vector. Actually, we can do it easier. I'm going to do it this way. Okay. Cool. We got our loot boxes. Here's all of our loot boxes. Guess what we're going to do? You get your parents' credit card. Don't do this literally. But you are going to buy... How many loot boxes are you going to buy? How many loot boxes will you buy? Who's going to buy some loot boxes? Who's going to spend... They're $1 each. 5. He didn't win. Here, I'll give you 5 more. Dang it. 100. You might... Nope. You did not win. 12. You know what we can do? Watch this. Let's do 100. And now let's take this and let's make a table. So look at this. We got 2 winners. 2 winners with 100 loot boxes. 2 winners again. 3 winners. Wow, sometimes we get a few winners. The probability of winning is 0.5 or 1 in 200. So you know what's funny? If we buy 200 loot boxes, we should generally see about 1 winner. There's 1, there's 2, there's 2, there's 1, there's 0. And you know what you could do? Watch this. Here's the fun of this class, which we'll do later. Is you could go right here and you could say like, we could say total. And then we go here 4. And we go for I in vector 1 through 1,000. And then we go total. Position I, save into, and... Oh, and then we need to go to position winners, but that might not exist. You know what we could do? There'll be enough losers. So let me do position 1 of the vector, which is always the losers, and then 200 minus this. And I think that'll do it. Cool. Yes. What have we just done? Does anyone know, for 50 points, what I just did? Can anyone explain to me what Brian just did? Because now... Oh, it's so cool. I don't like the bin widths on it, did on it. Let me actually turn it into a bar chart. Oof. No. I know, I love for loop. Andrew, you're cracking me up. 5 points, Andrew. And Vidrana, right there. Let's do this. Yeah, that's the way why are you doing bin widths like that, R? Why are you doing bin widths like that? So, what we have right here, created a... Yep, toss. I'll give you 20 points right there. I said 20. Whatever I said, toss, you got it. So, now I did it 10,000 times. So, what I did is I bought 200 loot boxes 10,000 times, and I looked at how many winners there were. So, I bought 200 loot boxes 10,000 times, and what did we see? You know what's funny? We could just... Probably a table might work really well. Stop giving me graphics errors. There we go. There was a time, and look at this. It's centered around 1, but there was a time where we bought 200 loot boxes and we won 7 times. But this is 10,000 trials of buying 200 loot boxes. So we did a simulation of buying 10,000, or we did a simulation of buying 200 loot boxes 10,000 times. And it literally does it. Oh, it does take a moment. You know what you can do? Here's a cool command. We can find the system time here, and then we can do this. We can do system time minus start. And now it'll tell us how long it took to run. So that right there stores this time. It took 1 second. It took 1 second, barely over 1 second to do 10,000 simulation. So system time, if you notice, what this function does is it just calls the system time. There's the system time. And then it stored it into start, and then I took the next system time and subtracted the start. So you can evaluate how long your functions take to run by running something like that right there. System time is just a function that takes no arguments. It might have some, but I don't use it with any arguments, but it can be ran with no arguments. What do I mean by it having no arguments? Look right there, no arguments. So once again, I will post this file. I know I did just code a lot, but that was meant to be kind of a cool look into the future, because, man, I love coding. You can do so much. Do so much. We did some loot box stuff and went crazy. So here we have letters. Cool. Letters is a vector stored in R by default. You can call it. What will this... Here, let's do this. What will this put to the chat? 5 points. Who knows? What will this put to the chat? The other languages I know so little of. Like, do I know them? Do I know Python? Yeah. Rep repeats something multiple times. Yep. So that puts B. If I go to rep B, what will this code produce here? What will this code produce here? Great question right there, Alex. 10 points, Alex. Thank you for asking me to repeat something. What will this code... You asked me... You wanted me to repeat that. You said rep the rep function. What does this code produce here? Before I run it, you should kind of think of what it's going to produce. There you go. Yep. It repeats it 3 times. And that's what I was doing up here. I was repeating winner 5 times, and I was repeating loser 99.5 times. Great job, Nitin, right there. Extra 5 points to Nitin for putting the quotes around it since it's a string. Yep. Don't worry. I knew what everyone meant. I would probably put PPV in the chat too, but I was like, oh, strings. Referring to vector elements, we've talked about this, that we have here the square brackets. We should know square brackets. A lot of people have asked multiple times, or I think every class has asked, why is this 1 here? Because that is the first element. If I were to do something like this, then this is the 993rd element of a vector that repeats B 3,000 times. And so it can be really helpful to use things like rep, because you can write things out super quick. You can just repeat something multiple times. And you don't need to even repeat the same thing. The notes show that you can go here and do rep and do something like A, B, and then C, and you could rep this, let's say 6 times, and it just repeats that. So you could create like a repeating sequence and just repeat it over a certain length of time. So it's really valuable, really good. You're just like, I just want to repeat this, boom, whatever you want to repeat, and then how many times you want to repeat it. Awesome stuff. And thank you for all the questions. Please ask when you're like, how do I do that? What is that? There's vector positions, our square brackets. We see that. Omitting, this is the NAs, is it? Oh, everything but. So when you want to remove something from a vector, you can use the minus. Let's look at this. So we have right here, let's go to a vector of 1 through 10. There's our vector. We're just going to call it x. It's saved as x now. What will this do right here? It's simply going to remove out 5. So it won't put an NA in there, but it'll just remove out 5. It just removes that element when we show it or use it. And I believe if you want to concatenate, you can do things like -1, -2, -3. And that should work right there. You can't negative concatenate. That always kind of, that's one of the ones I always forget. I'm like, wait, is it minus concatenate? You concatenate the elements you want to remove, which I was just doing this code with someone else recently. I was helping out with a student's project, and they had to remove stuff. And I was like, wait, is it minus concatenate or concatenate minus? So it's like, these are the elements I want to remove in the concatenate. So that's got it right there. I think people should understand how to remove things. Let's see. The which command. Oof, we got to slow down here. The which command is what gets people. You ready? We're basically reviewing my video now. So if you pay attention here and then you watch the video, you should be good on the which command. What is the which command? The which command takes inside of it let me just think of yes. Just trying to figure out how to write it. Okay. Give the true indices. Yeah. Wow. Andrew, amazing note right there, Andrew. It gives the, let me just copy paste that into our notes. Gosh, you help me make videos, Andrew. And let's go. I'm going to take this. Whoops. There we go. I hate that it does that when we do this. There we go. Gives the true indices of a logical object, allowing for array indices. So this whole thing right here is a logical. You see where I have the condition? So this is basically which basically takes a logical check. Like that's the abbreviated version of it right here, which basically takes a logical check. So let's take right here, and you could literally go which, and you could go true, true, false. What will this which return? Look at what Andrew said. Gives the true indices of a logical object, allowing for array indices. And so the array indices is the array in dot index equals true. You can do for that. It allows for that. So what will this code return right here? I would put this code on your test too. If you know what which does, this is a very easy answer. And then read what Andrew put as a note. I think this is a great test question on do you know how to code, which could be on your midterm. I would love, we might just take this question, literally put on there. So wait, it returns the indices. That is like the positions. Toss, nice job. Toss another 5 points. You got it. 1 and 2. It returns positions 1 and 2. So does everyone see what it's doing? It's telling us where the trues are at. Let's do a number line from -4 to 10. Does everyone see this number line from -4 to 10? We're going to call this numbers. And then we're going to do which numbers equals 0. So what will this code return now? I'm giving him. Okay, I know what this code will return. What will this code return right here for 5 points? You got it, Adam. You're right. 5. Because it returns the position of the true. Now you could check where that true is at by doing the following. Does everyone see the true is in position 5? Because what's in position 5? Position 5 is 0. So that's where the true is at. And that's what it returns right here. Hopefully that makes a little bit more sense. It tells you the position of the trues or the indices, the location of them. So which returns the positions of a true. So we need to feed into it a logical check. So basically, it's usually what we want to check in the condition, which is a logical check. So if you look down here, this right here is just literally logicals. It needs a logical vector, so this works. But more traditionally, we'll do something like this right here. But you could do which survey 10 equals 75. And now it returns this. This is a bit crazy. It's doing, I think I can show it this way. When it does this right here, and I would not expect you to understand this, but I'll tell you what it's doing. It's going through each column, and it's reaching the end of this. It'll go down through the gender column and look for 75, and then it'll go down through the height column, and it'll look for 75. And then it returns, like, this right here is position 700. So this is very confusing, because this is position 1, this is position 700. How do I know that? Because there's 699 elements to the first column. When it gets here, this is position 700. This is position, like, what would this be? Position 1400, I guess. I think so, because we're lucky it's 699. That makes the math easier. And then this would be position 2100. So very confusing. But we don't want to do it that way. That's very confusing. We want to do array.indices equals true. And now look. Now it tells us where the positions of all the trues are at, and it gives us the rows and the columns of them. So now you can see row 15, column 2. Row 15, column 2 is row 15, column 2. So I'm able to search through this matrix and get the row and column positions for everything. And I believe what'll be interesting, I want to see what happens here. It says 15. That's the way it's doing it. That's the way it wants to do it. So 15, and then what would it do for the second one is going to report that. If I do concatenate 1, 2, 1544. So it's oh, I bet I know why. Row 15. Huh. I've never used it that way, but I use it this way a lot of times. And it's doing, or maybe we just need to do the reporting the way it's doing it. It's giving us clues. It shows us how to do it if we do it. It's like, hey, this is what this is called. This is row 15, both columns. So does that mean... Let me see. Out of script bounds. That's what I did. I thought I did. Maybe I did it wrong. So, do I still have the code I typed? Because I thought I did that. Well, that did work. Wait. Row 1, column 1. Oh, and then it has to be columns 1 through 2. That makes sense. Okay. I get it. Cool. Columns 1 through 2. So that does make sense. It is a data frame that it's reporting. So literally you could take this right here and you could store this into a data frame and then you could take a look at it. And there it is. So it is just a data frame. So it has rows and column positions. So you have to call row and column, and that's what we're doing right here with the rows and columns. Please note this. This right here is the row column positions, and when you have something that is two-dimensional like this is, you have to use rows and columns. This is so key. So let me put this in the chat, and I want to see you guys echo this right here. So this is one-dimensional, I'm going to spell it, and then two-dimensional. So that's one-dimensional and two-dimensional. One of those dimensionals is spelled correctly. Yep. And you see where we have the comma? It's huge. Adam, 20 points first person right there. I want you to know that the one-dimensional does not have the comma. The two-dimensional does. And this is the row space right here. We're just going to blink across the screen, are we? This is the row space, and this is the row space right here. This is the column space right here. That's the column space. Nice job. Make sure you know that. It's a lot of people make that mistake. You just have to know what's the dimensionality of the data frame I'm working with. We got a lot of time left. We know what the which does, and we have logicals. I have a really good video going over logicals. So if you're looking at how do they work, one of the biggest ones to know is the equals, and also the percent in percent. Now, percent in percent often confuses people. What is percent in percent? Okay, here we go. Is 2 contained in the vector? I just want someone to answer me true or false. Is 2 contained in the vector 2, 3, 4, 5 right there? Is 2 contained in the vector 2, 3, 4, 5? True. Boom. That's it. Is 6 contained in the vector 2, 3, 4, 5? 5 points, all those answers. False. Is 2 contained in the vector 2, 3, 4, 5? Is 6 contained in the vector 2, 3, 4, 5? True, false. But now we have to be careful, because now we see the difference between percent and equals equals. Is 2 equal to 2? Is 2 equal to 3? Is 2 equal to 4? Is 2 equal to 5? What will this return right here? Listen again how this code runs. Is 2 equal to 2? Is 2 equal to 3? Is 2 equal to 4? Is 2 equal to 5? If you notice, I go through the whole vector. You know, it's interesting. You can always do things like this. R recognizes that. True is also equal to 1. If you didn't know that. True is equal to 1. So what is 0? 0 is false. So you got it. Nice job. Nice abbreviation right there. Yaxi, Yaoji, 20 points right there. I'm throwing out crazy points. It's Crazy Point Fridays. How about this? But what will this code do? This code confuses people. Nice job, Andrew. 20 points, Andrew. Crazy Points Fridays. Frenzy Friday, we called it on mini term. So I'm just destroying the point economy already. So right here, what will this code do? Is 2 equal to 2? Is 6 equal to 3? Is 2 equal to 4? Is 6 equal to 5? Does that everyone hear that? Is 2 equal to 2? Is 6 equal to 3? Is 2 equal to 4? Is 6 equal to 5? That's what that returns. It goes through and does 2, 2, 6, 3, 2, 4, 6, 5. Checking them that way. That just confirms that the last one we checked was 6 equal to what the last element is. So these are different. So you have to look at these, you know, very carefully. Because what will this code return right here now? What will this code return now? What will this code return? And be careful, that last code only did 4 things. What will this code return right here? What will this code return? Careful. You're close. It won't just return true. It won't just return true. Close. 20 points first person. No one's gotten it yet. Alan, 20 points. Because it says, is 2 contained in the vector on the right? Is 6 contained on the vector on the right? It checks each element. It says, is 2 contained over there? Is 6 contained over there? And that's true, true. So it's a little tricky. This is one of the harder things for people to get straight between the equals equals. So listen again how equals equals works. Is 2 equal to 2? Is 6 equal to 3? Is 2 equal to 4? Is 6 equal to 6? Then when we change it to percent, we're only asking 2 questions. We're asking, is 2 contained on the right? Is 6 contained on the right? So it's a little bit, I like that right there. And then 1, 1, you are correct. It does return 1, 1 because it's true, true. So those are pretty tricky. I go over it a little bit more in the video, but just takes practice. It's a lot of practice. Is.na is how we see if things are NA. So you could take a vector. And you could take, didn't we have a vector with NAs? Sure, let's go here. Go. And then we go here to is.na and x. And there we have where the NAs are at. So you don't do equals equals NA. I think it gets mad if you do that. You just see if it is NA, and it'll tell you where the NA is at. So NA is in position number 11 right here. NA is in position number 11. Here's more logicals. The and right here and the or. So I do mention this in the logical video, the ands and the ors. So you could say true and true. And that is true, but you could say true and false. This will be false, And you could say true or false, and that'll be true. The way this works is to have an and return a true, both statements have to be true. Everything you join with ands. Like I could go here and do the following. And this code will return true. But I could go here and do the following, and this code will return true. Because ORs just need one true. Imagine this. The ORs are like this. If you're going to like say, we just need one person who's been in professional baseball to be here. It could be this person or 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 this person. But the ands are almost like you're going out to the club with your friends. And you say, everyone needs to be over 21 for us to go to the club tonight. Imagine that. You're making plans with your friends. And you say, everyone needs to be over 21 to go to the club tonight. Like we were thinking, hey, let's go out. Let's do this. It's an over 21 club. So everyone needs to be over 21. And then your one friend is not. So are you going to the club tonight? So with line 94, are you going to the club tonight? Yes or no? Because your one friend's not, they're 20. They're like, 2 more weeks and I'll be 21. Yeah, I'm from New York, from Massachusetts, or New Hampshire. I don't know what the accent is. Poor guy. Nope, no club tonight. Not doing it. Does everyone understand how the ands and the ors work here when they join statements? And of course, these can be logical checks. You could do the following. You could do is 2 equals to 2, and also is 3 equals to 3. This will return true because both statements are true. You could look to see what these evaluate inside of here, and it does that. But you could change this to a 4, and that would be false. Change this to an or, and you get true again because one of those statements is true. So why does this evaluate to true? And I do like this idea of putting things like this on the test. Would you guys like something like this on the test? And do you know how you should do this on the test? Is you should go here, and you should evaluate this as a true, and then you should go here and evaluate this as a false. And then all you have to see is that you're connecting with an or. And boom. You can see it's just like, okay, it's a true or false. Since that works this way, got it. Once again, we need to make on the Discord like questions Brian should ask on the test. And I think that's a perfectly fair question. I think that is a really good, just do you know how this code works type question. The answer is, what does that evaluate to? It evaluates to true because it's connected by an or. 2 equals to true, that is true, and this is false. So that is a really good general do you know how to code question. So once again, if we make a coding channel. So Dennis, if you're here, if you're listening, oh, Dennis is in 320. Dennis, we need to make things like questions Brian should write on the test. I mean, it would help me out and it'll help you guys out because it'll be like example questions. Percent in percent, we talked about that. Note on selecting elements of factors. So Dr. Petrie, why you do that to me, Dr. Petrie? So let's say right here with the which and the u, all this good stuff, more on which. The subset function. Whoo, we got enough time today. We got this. Okay. The subset function. When you do subset, the first argument of the subset function, Dennis, you're in? Yes. Dennis, you're awesome, man. The first argument of the subset function is what do we want to subset? And then the second thing we usually do is the conditions. So I can go here and say gender equals to male. And then I could say and height could say greater than or equal to 70. And did we delete weight? And GPA greater than or equal to 3.5. There's our subset. We can store our subset into something called X. And please note what I really like, and let me mention this again before I change the format. Does everyone see how this staggers inside of it? Notice how this is the first argument. This is the second argument, which is the first argument is what are we subsetting? And then the second argument is the conditions, but we never left the second argument. How do I know we never left the second argument? 50 points. First person to tell me, how do I know Brian never left his second argument? How do I know Brian never left second argument? This is huge for this. How do I know Brian never left the second argument? I don't know. No. What do you... No comma, Jordan. Well earned 50 points right there. no comma. Notice how now it re-indented to this right here. Let's go to... Sure, why not? And now we only get those columns right there. I can't speak. But if you notice, select selects columns for us. Just notice how this works. Is I could also put in here the height of the individuals if I want. And now it'll do this right here. And I'm just printing it to the screen, not saving it to the environment for the moment. But do you notice here how this is the first argument? What are we subsetting? The second argument is all of my conditions, and it goes right to the comma. Right to the comma. And then my third argument, which takes the vector of the columns I want to select. So the third argument is select these columns, and I have to put the columns into vectors. So what happens if you keep it all on the same line? You can. It'll look... Caroline, I'm throwing you 20 points, Caroline. You can. It'll look like this. Space doesn't matter there. We won't put a space for this one. I hate this. No. It'll look like that, and it'll do the same thing. So I like to make my code look like this right here. To me, this just makes it easier to read. Like, here's my first argument, my second argument. I'm continuing my second argument. Here's my third argument. It just helps with the reading of your code. So I suggest that whenever you get to the end of a line, you can usually hit enter after these. It'll read through the ands. It'll read through the commas. Just learning how to make your syntax look nicer makes life easier. So as you can see here, this is what I want to subset. First condition, second condition, third condition. And then here's what I am selecting the columns based on. So hopefully that makes it a little bit easier. Just try to write your code as nice as possible, and I can help make your code look nicer. Subset, cool. There's a lot to do with subset. There's a lot to practice with it. So definitely, I didn't jump something. But subsetting, lots of ways to do it. Named vectors, yes. 1111, make a wish. I wish all my students get A's. Let's make that happen. You need to, if you're watching live and you're working hard, 1111 just produces 11. There we go. And let's look here at named vectors. Really interesting enough, a named vector, a table will make a named vector. When we make this table right here, you can actually call the positions with names. So let's just call this X right here. And when we call X, we can actually call position gender. Which, oh wait, what am I doing? Position male. There we go. Position male is the same as position 1. Oops, position 2. That's what it is. There we go. So if you notice, a named vector has names for the positions, but positions always have numbers. So a named vector has names for the positions, but positions always have numbers. You know what you can do, though? You can unname a vector with X, with unname. You could overwrite it. And now it's just a vector of numbers. So look, as we have here a table that is a named vector, but you could simply remove the names and you just have the vector. So those names are not actually things that exist. They're just names of the positions. It's like a street address. It's like, this is the street address for the first position, but it's still the first house on the street. You could say, what's the first house? Well, it's this house. This house right here is the first house, and it's named female. So you could call it, we'll remake it, and you could say, well, first house. There it is right there. We've got time for one more topic. Let's do it. We start on time. We end on time. That's what we do. Growing our appending vectors, deleting elements. We did that. Oh, man, we've done all these. To grow or... Oh, I didn't really say it. I did it today, but you might not have seen it. If you want to grow or append a vector, you can simply concatenate onto it. You saw earlier when I grew a vector here, we had the vector 1 through 10. And I went and I just concatenated it. And all I did was add to it the next element, NA. So I was able to append on to that vector right here. You could also append two vectors together. Like if we had a vector y right here, and we had y being 20 through 100, we could go here and we could concatenate the vectors x and y, and there we go. You can see where my NA is right here, but that just appends the vectors together. You can also go, and let's do this right here. We could go to y, and we could take y, and we could overwrite position 2 with Brian. Now this is going to change it to a character vector. We can see it right there. So we're doing a little bit of review right there. But position 2 was Brian. This is position 81. Position 100. Last question of the day, 50-point question. Brian is now appending Darren to the 100th element of Y. I want you to think what's going to happen here. There's nothing between like 82 to 99. Those things don't exist. So what will go in 82 to 99? Darren will go in position 100. But what will go into 82 and 99? What will go in 82 through 99? Because there's nothing there. So what will go into those vectors in those spots? Last question of the day, 50 points. We're ending right on time. You got it, Nin. Boom. You said it. There's nothing there. I said it. There's nothing there. So we added Darren to that position. We changed the way R sees that vector and NAs. And make sure you do capital NA. Just double check. I know it's NA like NA, but capital NA. And this was a really jam-packed class. Thank you so much. If you're here right now, you get your full 20 points. I really appreciate it. I know it's Friday. We start on time. We end on time. Really jam-packed class right here. Lots of coding. Do you guys feel better? Is it making sense? I'm going to go ahead and save this file right now as the May 29th. I'll make sure to upload these. So let me save this as our file right here from class. So if you want to take your own notes during class, I highly suggest it, but I will try to upload the files. I know it's a lot. This is like your refresher. I'll try to get data camp out there. I'll try to post more videos this weekend. Watch the videos I have up. It's just about practice. During summer, don't take a weekend off. Be like, okay, I just got to sit down. I got to code for maybe like an hour or two. I'll post the assignments. A lot of info, but it's great. Awesome. I know we really did some concentrated work, and I will post these so you can get some practice. But today was a very concentrated day. So, but if you understand what the code is doing, and I want to make, if you notice, a lot of my questions were, what is this code going to do before I run it? Because the first, either Monday or Tuesday, so I'll post it. So definitely take a look at it. Remember, when you're stuck on anything for more than 5 minutes, email me. Don't look at it for like an hour and be like, I have no idea what's going on. People are so far along with their points. That's awesome. So whenever you're stuck, don't work on it for an hour and get stuck. Email me after 5 minutes. Brian, my code's not running. What's going on? And remember how to email me. Use your course title, and then use tell me your problem. Send me a screenshot of your problem, and send me your RMD. And great job, everybody. Really great answers today. We're moving right along. We'll get to some more complicated stuff here soon. Lots of notes. And I will say this, the notes are very, very thorough. And sometimes I go a little quick on a page. Yep, we're in the same. Basically what BZAN is it's the graduate version of the course. And so you're allowed to take that course with no prereqs. So they do BZAN. I know you guys are doing awesome. Andrew's got a head start on you guys. You're welcome, Nitin. Man, I love the positivity. And I'm really interested in the stat stuff that you might be doing. That sounded really cool. I know Madeline's got some great points. Man, you guys are doing awesome. It's awesome. I know you can watch the other class too. If you're watching, if you're hanging out, that's fine. Get some extra points. Jump in those other classes. It's a good way to get our channel more. So, no, I really appreciate it. Like, you guys, and then you can ask questions right now. We could, do I have the first assignment posted? While you guys are still here, remember, this is office hours now. We're just kind of hanging out. I think next week will be a lot more serious during office hours because we'll have a lot more work to do. So we'll see if people have questions. But let me go over here to 474. Let me grab assignment 1. Let me see how it's looking. Assignment 1. Assignment 1 is posted. It says it's due July 9th. Okay, let's take a look at this. Let's take a look at assignment 1. There's the equations. So this is not available yet, is it? Did I post the solutions? Go to files. Is this one up the correct? It looks to be. And then making adjustments as we speak. That says it's available after. Oh, wait. So it should. Let's see. Questions in the chat. Why is it? Oh, it's not due July 9th. So is that what you guys see? Is that solutions are locked? Yay, I locked the solutions. Good. Yay. It's not due July 9th. The solutions, I just moved everything to July 9th because I was just moving everything way out in the future. So that's good. You guys have confirmed for me that the solutions are moved out to the future. So that's good because I was like, did I post all the solutions? No. So the solutions are locked for you. It just doesn't show that they're locked for me. Oh, I can go to student view. Let me do that. That'll just give me some peace of mind. Settings, student view. Sorry, you guys are watching me like just randomly looking at stuff. Where's student view? Student view. Student view, my course. Assignments. Homework 1. Working with data. Is it? Wait. This file is locked until July 9th at 11:59. No wonder everyone's like, wait. Okay, so I'll load up. Last semester starts in the mini term. So, oh wait, Dennis. Other class. Oh yeah, you guys see each other right there. And so this is the correct assignment. And let's see right here. Let's get the. I keep downloading the solutions. Oh my gosh. I have broken this. Okay, here we go. Let's get the RMD file. It says summer 2019, but that's all right. Here's the RMD file. Should be opening up. Awesome. I'll probably be making some changes as we go on. So can I post the invite link to Discord? Yeah, exactly. Yeah, send me the invite link via. You sent it via email, right? Yeah, let me send it out. Dennis, I can send it. I can send it via email. Send me a reminder and say, hey, Brian, send that Discord link out to everyone. And I really appreciate this. We'll get it going strong. So we'll get it going strong. I really appreciate it. That's, I think, a great way for us to have interaction and everything. So thank you so much for making that. Let's see. Are you guys ready? Do you guys want to do a little bit of the first assignment right now? Shall we do a little bit of the first assignment? Shall we do it? So we have to solve some math right here. Let's do it. Let's solve a little bit of the math. You ready? So we need to solve a little bit of math. Let's solve a little bit of this math. Okay, here's what we need to solve. So we need to solve this right here. And let me get the chat back up. Okay. Yep, let's do it. Let's do a little bit of that first assignment. Okay. So we need to solve the math equation. Where's my math equation at? I'm going to screenshot these so I can pull it up a lot easier because I'll know where my screenshot's at. So I am just going to screenshot this right here. Oof, that bottom was a mess. It's horrible. Why do we do that? Okay. So we need to do 1 plus the square root of 2, 2 plus the square root. About the assignment 0, but right after I emailed you, I figured reply to the email and just be like, I got it working. So yeah, no, it's awesome. What if red class won't load? No worries, you won't need red class for this one. We'll try to fix red class. Vidrana, email me and we'll try to fix it. But no worries. Who can just write this first thing right here? Who can write this first thing in code? Who can write this first thing for me in code? Who can help with writing this first thing in code? Try writing that in code right there. Who can write that in code? Who can write that? Yep, let me I'm gonna steal Andrew's code right here. And then guess what? We can take this. We just got to delete this. And then the pattern was... Okay, then I'm going to purposely put in an error here. There is purposely an error. I might not even correct it. I might leave it in here. 2335. What error is there right here? Yep, you guys see it. You already see it. I can't trick you. I can't trick you. You know it. This won't run. We'll say attempt to apply non-function. Boom. Destroyed. Dab on that. It's horrible. So they were posting dabs earlier in the chat. But no, we just wrecked it. That question is destroyed. Look at that. Go right here. This one's a mess. I would code this bottom thing first. So when you usually code stuff, you code from the inside out. So once again, these are all really messy. And the answers here tell you what you should get about, so it's not too hard to get. But code the bottom part of this first. 1 plus square root of 8. Well, we just did that. We just did that right here. Now, here's the biggest thing. You hate logs. I do too. When you write something, run it. And I think I did it. Did I do it? Oh, I did the whole thing. So when you write some bit of code, run it. So whenever you write this right here, run it. And then we just need to log it. It's log base 10, which we can do the following way. This right here works. Or this right here works too. We saw this today. You could take and go second argument 10. That's the same number. So just so you can see, it's the same exact number right there. But either one works. You can call the base or the log10 function. I didn't mention it, but it was in the notes. Log10 function can only use log10. It's log base 10. And I hate logs too. I mean, they're super important, but it's log, it's log, it's log, log. It's big, it's heavy, it's wood. It's log, it's log. It's better than bad, it's good. Does anyone remember that besides me? Does anybody? This is basically done now. Now it's just being careful. Yep. Now it's just following through the rest of it. Be careful as you do it. Just use your parentheses and evaluate each part of it. And just follow through each part. Be very careful. I would not do too much at a time. I'd be like, okay, that is done. Then you go here. Here's a trick. Try this right now. Highlight some code. And then put a parentheses around it. Did everyone see that? You highlight the code. And then you just do Shift 9. Way easier. You can also... I wish it didn't do this. You can double click a line. You can do Shift parentheses. It closes it on the other side, which I hate. I wish you could just double click the line and then do the Shift parentheses. But you can highlight code. Oh, don't worry, you're fine, Andrew. And yeah, I think we might. I mean, how do these look? If you just follow through and be very careful with your coding, does everyone think I mean, it's a mess. Just write this individual part out. Add it to this individual part. And then you're basically done. What function will we call for this right here? What function will we call for what I'm highlighting right here? What function will that be called with? How will we get those absolute values? How will we take the absolute value of whatever's found inside there? Any ideas? Chat is stumped. Sometimes I wonder if I've stumped you or if you were just being quiet. How do we get the absolute value? ABS. Absolute value is ABS. So, yep. ABS. Good practice. Yep. Just the more you try to remember it, the more you practice it. And so we'll probably... You take the absolute value of like that. And there it is right there. So it's ABS. So how do you guys think about these question ones right here? Pretty good? Pretty good on these? Like, yeah, we got this. I got that. Those are not bad. Just gotta be very careful with my mathematics. And then you get the checks right here, which you can check your answer. So you can check your answer if you did it correctly, but once again, do it in parts. Don't write the whole equation out and then try to run it. Everyone, please note this. Do not write a ton of things and then try to take and run this whole thing because you'll get an error. Now, where is my error at? I just wrote some randomness. This is obviously not the answer. But if you had written all of this out at once, it might be hard for you to see the error. Yep, and that's all it was. The last thing right here, now it runs. Now, that's not the answer. So hopefully I don't see that on assignments. But if you don't run your code eventually, you'll have a whole bunch of code, and then there'll be an error somewhere that you can't find. I mean, you'll hopefully find it. But run your code as much as you can. You'll see that I usually do that. I'm usually running my code a whole bunch, just seeing what it does. And I made errors today in class. And because I was writing short little bits of code, I was able to get it. I was able to notice it a lot quicker. Because the longer code you write, the more there is to check. Practice making sequences. We got this. So I'll let you guys put, we'll do like maybe the first parts of each of these. Maybe. Here, I'll put that in. Someone, here, wait, delete. Don't delete it yet. I'm going to copy it. That might be it, man. There's so many parentheses. All right, let's see here. Whoa. Oh, because of it copies a special character when I do this. 2.538. You can pause the video. That looks to be about right. Yeah. Yeah, it looks to be all right. Nice job, Andrew. I mean, you're just crushing it, Andrew. That is awesome. You guys are doing great. We'll do like the first ones of a lot of these. So this is a huge help right here. We're just doing, a lot of the problems are similar. So if I help you with the first one or so, then you can be like, oh, well then I just have to do it kind of the same way in practice. How do we make a sequence that starts at 80, goes to 100, and goes up by increments of 1.5? You guys can put this in the chat. Who here can figure out how to make that sequence? Who here can figure out how to make that sequence? Any ideas on how to make that sequence? You can do it really quick. Make it really quick. And there's two ways. I'll point to the two ways of doing it. Let's see if anyone can write in the chat for us. You can put this answer in the chat. If I'm saying, like, what's the answer? Yep. Andrew, great job. That's the exact... And you can leave that in the chat, Andrew, because I'm going to leave this one up. This is the quickest way to do it. And then if you want to put in these, you can. And that's the same sequence right there. Yep. And so no worries. Madeline and Andrew, 5 points each, and Ahmed and Jordan, and these are extra added on to your class. I know you're getting crazy points today, but that's fine. I like you guys being here working on it. So Madeline, what you would get, so really good right here. Madeline, your vector would be, just so you can see, and just run it to see what it creates. Yours is going to create a vector of numbers going from 80 to 100, with the last element after that being 1.5. So it'll append onto it, the last element being 1.5. So you can see it down there at the bottom where it creates the vector of numbers. And this is the quickest way to create a vector of numbers, but it does it by 1. And then you append it onto it, this number here, because the first argument was, here's what we are appending, and it's going to be appended onto this. So great thing right there. I told you to do that so we could practice it. Another 5 points, Madeline. Just like, I was like, put that in there so we can say what it is. So, but no, really good stuff. And these last few ones right here, when it asked for 9 total elements, what argument we would use for that? Thank you, Madeline. Can anyone tell me what argument we would use for 9 total elements? What argument? Don't put the full function in there, but what argument would we, yep, you got it. Yep. How easy. Look at how far we are down. Now, the start of it was a lot of instructions, but it's like we're already crushing this assignment. We're just destroying it. This one right here, we want to write the following sequence. 1 plus 1/4 plus 1/9 plus 1/16. This one's a bit tricky. I'm wondering how much I want to give away of this. Don't put the answer to this one in the chat. Casey, that looks to be right. Remember, remove it so people can't see later on, so they have to do it. That looks to be right, Casey. So if you're watching live, that is the answer. So go to the remove. So so people who were not watching live, like, no, I didn't get the answer. Everyone else is like, copy that answer. But if you know how to do it, it's like, okay, we got it. So you just click over your chat and then you just go to remove chat. Wait, can I remove it? Whoa. So you didn't say anything wrong. I didn't know I could remove moderator things. So you didn't say anything wrong, but so there's not too many answers, but there's still a lot of answers. Let me say, yay. But that is totally right there. My chat wasn't moving down for some reason. So, and then you retracted it. Yes, perfect. So don't worry. That's the only thing. Yeah. Mods can still view it. Oh, man. Yeah. It's too funny. Casey, 5 points. I told Casey to do it so we could just crack up. Man, office hours are fun. I tell you. I just have fun here. Okay. So, it might only be live. I think so. It's hard. You can't read it. It's grayed out. That's so hard to read. No one could read that. How can you possibly read something grayed out? But also, if people come in and say mean things, their chats will be grayed out. No one's ever saying anything too crazy. YouTube actually blocks, like, I think you can't even say something really, really crazy on YouTube. And then if they do come in, they say something like that, we just gone from our chat. Like, don't worry. So, Casey, don't worry at all. You got 5 points right there. And so, oh yeah, I put in this. So, do I have the mass package? I got it. There it is. Okay. Okay. So, so we got the helps and everything. So, I kind of want to do this one. I kind of want to do it because it's fun. What you can do is you can make a sequence of number 1 through 40. How could we turn this into fractions? I'll let you guys solve this. I'm going to let you guys solve this. How could we turn that into like 1 over 1, 1 over 2, 1 over 3? How could we do that? How could we turn it into 1 over 1, 1 over 2, 1 over 3? If you notice, I'm running it each time, and I'm doing it in parts. I'm not doing everything, because we're not answering the question 1 over, this is technically that. And then this is 1 over 2 squared, 1 over 3 squared, 1 over 4 squared. Well, I just want to do 1 over. I just want to do 1 over. Pretty much. Ahmad, you're right. So we're just going to go 1. There we go. And watch this. Now we use the fractions. Also, you'll see me a lot of times, I'll put a space, because if you don't put the space, the autocomplete won't run. So when you write 3 letters, autocomplete starts, but you have to have a space. Like if you start doing this, it's reading that as frac 1, like fraction 1, and it won't autocomplete. So when I'm typing something, I'll put the space a lot of times, and then I'll write, and then you'll get your autocomplete. If you mess it up, you can go backwards and see what you have. So I'm going to go fractions. I'm going to open the parentheses. I'm going to close it around it, and I'm going to take a look at it, and look at that. But that's not what we want. We want to take this down here, and we want to square it. So I'm going to put another parentheses around it, and I'm going to square it. Done. Now the last thing that it asks is the sum, right? So it says, what is the sum of it? Figure out how to generate the following sequence. Does not say, oh, print to the screen the sum. So don't forget to sum this. I will say this, sometimes I forget something when I'm doing assignments. I don't make hundreds either. I make 95s. So, and I write the assignments, just throw it inside of a sum. Great job, Amit, right there. And if you notice, what am I doing? I'm going to highlight this right here. I'm going to put an open parentheses around it, and then I'm just going to go in front of it and write sum. So just look at those steps and try to repeat them. It's just how to code quicker and faster. I mean, I guess it doesn't hurt to go in front of it and write sum. And I wish I should know. Dang it, that's how you highlight stuff. I try to learn all the quick keys, but I forget them. Like Control-Shift, you can highlight faster. So you can do faster highlighting with Control-Shift. Let's go back to question 2. What are we doing? There we go. Right here. And so that's that one. Real-world data often contains missing values. So these are NAs. It wants us to create a vector here with these numbers, the log of this, the log of that, and all this. Make sure this. Make sure you see the value when you take. Print the contents of BAS to screen. You'll see integers as well as 0. I'll put the numbers of the elements. It should be 9. Make sure you see the value of that. Okay. So this right here. Here's a hint for this one. I'm dropping major hints. Is when you create your BAS vector, how am I going to join these numbers together into a vector? Drop the hints in the chat. How could I join these numbers together in a vector? How could I join these numbers? How could I join these numbers together in a vector? Yep. And I would just start changing this. Now this, don't do this. This is not going to run. So what I would do is I would start, I would start changing this to log of this, log 10 of this. Like I would go here and I'd go log 10 of this, and that's been fixed. The cubed root of that, change that to a cubed root. The number e raised to this power. I mean, we're almost done with this. That's almost done. I'm going to change this now so we can't get all the answers. And I'm going to change this to the vector 2, 8, it's not 8, 10, log 10 of that, and e raised to the power of 2. That literally, oh, and then we'll do quad root. the quad root of 1664, 256. So the quad root of 256, which I think is 4. So, and then quad root should be the quad root of that. It's 4. So, because 16 times 16, which is 2 squared times 2 squared, and powers multiplying together. So we have right here, powers are added together, aren't they? I think so. Worked out. And so we have right here the BAS vector. And we can take a look at the BAS vector. That's what's stored inside of it. And then we could run some stuff. These are not the right answers. So I don't want someone to watch this and then just copy what I do. I want you to understand how to do it. I want you to be like, okay, concatenate joins things together. So you add commas between them, and then it's solving all these things inside of here, which is, this literally shows how to do it. We have right here bogus values. So imagine that these are bogus values. So let's say the value of 2 is a bogus value. So how about this? Which, right here. So let me do it first this way. No, we want to that. And the shortest single line, compass task. Oh, because it's, let me think. The way it's, I know a way to do it. There's lots of ways to do this. So, because we're replacing bogus values. So we want to, I was thinking equals equals. Would it not be? We want to find out, that'll find out if they're contained in it. Imagine the bogus values. I think it's equals equals. I don't know why it says %%. I want to do it with %% now. But if we do, let's take 2 lines. How do I not remember how to do this? I've done this 1,000 times now. You can either write 2 lines of code, do something better, use the which and %%. You guys are free to help me out with this one. I want to replace 2. Imagine that 2 and 8 are bogus values. Sometimes I fake my brain not working, but today I'm just like, so is 2 contained in BAS? We'll get yes for this. It's true. So is BAS contained in 2? Yeah, it'll be right here, won't it? There's where it's contained in it. And then, yeah, that's the way I do it. Yeah, that's the way I do it. That's got it. Okay, figured it out. Brain's working again. So are the elements in BAS contained in the vector over there on the right? So now what we could do is we could go here. I just like solving stuff. I got to stop doing the whole assignment right here. Which, okay, what's this code going to return? Pause the video. What's this code we're going to turn right here? What will this code return? The positions 1, 2, and 3. Yep. The indices of the true. I need some wake-up music here. I might plug in some new headphones tomorrow with these. Need some wake-up music. I need some punch-out. Okay. So what could we do now? If these are positions, what do you think would go around it? If it's positions... If it's positions, what do you think should go around it? Any idea of what should go around it? Since it's positions. Because we're going to use it now as positions. I can see the rest of it now. Yep. And so what happens is, like if you do the following, this is a totally separate thing. If you go here to gender, I'm going to remove all the males. Sorry, males. There we go. Oh, it's lowercase, I think, because it's male. There we go. Here's all the males. And then I'm going to put the positions. Oh, we need a which. Sorry. We need to put this inside of a which will give the position numbers. So we could have probably just done it without the which too. I'll try that here in a moment. And then we go here and we put the square brackets and we go to survey. There we go. And that returns that. And then we go here. There we go. And now we got it. There we go. We have now removed all the males. Done. Gone. Because this which inside of here gives the positions. And then think of this as just a numeric vector. think of it as just a vector with the numbers of the locations of the males. So these were all the locations of the males right here. And it was just all the locations. And what did we overwrite the locations with? I mean, this literally shows by doing this how to do this one right here. Has anyone overwritten theirs with NAs yet? Has anyone figured out how to overwrite the NAs yet? Did anyone be like, okay, I think I got this? Don't put it in the chat, but does anyone get it? Because that basically gives it away. Because you just need to put it inside of square brackets to call positions on it. Because all this is right now, just look at this and say, okay, this is just the numbers, whatever the positions are. Now I'm doing a slightly different problem, so you have to work yours and think through it. Because I want you to be thinking, I want you to be like, okay, how does this work? So that it basically gives it away. Hopefully someone's got it. Like, I get more hints as, like, we get closer to the due date. But print to the screen your average of your updated vector. If we have here that a vector is missing elements, which I'm going to go here and I'm going to go to BAS, and I'm going to overwrite the second element with the NA. How would we print? That might work. But it's not a factor, it's numeric. It's not a factor, it's numeric. Ahmed, send me your code via email if you want to show me what you did. There's always ways to do things in code. It's not a factor, it's numeric, so we'd want to like search for it and then we want to replace it. But there's so many ways to do things. And you could literally write a function that could be called replace with NA. So like, watch this. If we go right here, I want to do it. I guess this would almost do it right here. Well, I'm basically kind of doing it. Do not write this all out. Do not do this. Did I lose it? Okay. So let me just make sure this works. It works. Good. Always run your code. Okay. And will that do it? What else is inside the BAS vector? 4 point. Those numbers are not fun to work with. Let me see if this works. Do this. Got it. So Amid, look what we have right now. We have a function that allows us to replace with NAs something inside of there. So this function I wrote, which is basically the answer to it, will replace any number I want with NAs. So I made a function called replace with NAs, and it only works. I could make it take more arguments like what we're inputting. So this could be data frame. Wait, not there. So this could be the data frame name, and then data frame would go right here. Data frame would go right here. Or actually, it's using a vector right now. It's not really set up for a data frame. So there's the vector, and there's the vector, and that should do it. And now it'll work on other vectors, but it has to take a vector, but it has to take like BAS right here. So it takes 2 arguments, and then it replaces with NAs whatever we have. So we can see it in action right here, to where we have this right here. And we could put in more numbers like 4, 4, 5, 5, 1, 2. And now we run it. We take a look at our vector. And we say replace 2 with NAs. And then we take a look. And all up. I broke it. Vector. What did I do, Ahmed? What did I do? Vector in... Oh, wait, does that not say? Oh, did I not call it vector? Uh-oh. I broke it. BAS percent. Which BAS percent? I have lost my mind. It worked a moment ago. Let me change it to BAS again. That's why you don't make too many changes. Now it doesn't work. Oh, because second argument. Okay, that works. So oh, because is it treating that as the vector of numbers? It's interesting. Oh, because BS. I think we still have the previous thing stored in here. That's interesting. I'd have to look into that. I don't know why that's not working. It broke my brain here, everyone. Why can I not have it do that? I might have to break it down. So what this, maybe that's, we'll try this. What this does is this is basically called super save, and it'll overwrite, like, it works with, it's a weird thing. It's like something I had to look up a long time ago. I call it super save. And if you notice, if we put the BAS right here, so it only works with the BAS vector, which is fine. If you do this, this is not, and actually, is it getting mad? BAS percent. Oh, because second argument. Go. And you see this did not change it, but then this overwrites to the global environment. More on functions coming up when we talk about functions and how they work. So that actually leaves function world and writes to the global environment. So if you do a single arrow, it writes to the function environment. If you do a double arrow, it writes to the global environment. So when you're running a function, you're in the function world. Does that make sense, Amid? When you're running a function, you're in the function world. But you can actually write to the global environment, which is outside the function world, by using a double arrow. So double arrow saves to the global environment from function world. It's like going a level up. Yeah, I had to look it up a while ago because I needed it, and then I've always loved it. And Dr. Petrie's always like, "Don't do that," and I'm like, "I like doing it. I want to break the rules." So that basically gave away that one. This one right here, if you have NAs in your vector, what do we need to do if we have NAs in our vector? Well, a lot of arguments right here, like if you do, is it median? So it doesn't want median here, but since it has two missing values, you have to print to screen the average. See, you get NA, but then I'll give a hint right here. Here's a huge hint for this one. I'm literally working so much of this assignment right now. But take a look right here. There are additional arguments to use, like the only one it's pointing out to you. So I've basically, it kind of explains. This is pretty obvious what to change. This is pretty obvious what to change on this one. Like, it's pretty obvious, like, what to put right there. Using some combination of which and is.na print to the screen the position of the two missing elements. So what does is.na do? Is.na tells us if something is na. There's how we see if something is na. And then how would we get that into positions? I'm not going to say, but is.na tells us if something is na. And once again, my answers are wrong for your assignment, but we got that right there. One of the simplest ways to handle missing numeric data is replaced with the median. So all we're going to do is go to the values of where things are in A. So if you think about this, we're going to go to the positions of where things are in A, and then we're going to use this as positions, and then we're going to go to the vector. So I'm going to say this. I'm going to say it in words. We're going to find where things are in A. That's on the screen right now. We are finding where things are in A, and it's mad at me. I don't know why. What? You don't need a comma? You don't. Cool. Really? Why is it asking for a comma? I know. R is being very mean to me today. So don't you ask for me that comma again. You learned your lesson. It was bad. You didn't want that comma. I gave you the comma and then you said no. So we have right here that we have is.na gives us the positions of the NAs. So these are where, gives us true falses for if things are NAs. Then if we want to get positions out of this, we need to use another function. Some function up here to get us positions maybe. And then we can use those positions to go inside the vector. Like we want to use the positions and use them as positions, like inside of here. I'm basically telling you how to write this. And then you want to store something, not NA this time, into those positions. So you can use the positions inside of here, which these are not positions yet. These are trues and falses. Sometimes I think you can use the trues and falses, but that pretty much handles it. That's that one. Here we go with using the box office data right here. This stuff is not so bad right here. You have to load the movie data set. Why is it mad at me so often? This is currently not downloaded. Let me go ahead and download it. The box office data set is right here. Where's box office? Movie box office. And is this an environment? So this will load the environment right here. Oh, seriously, it's going to do that. Workspace image. So you have to go over here and we have load this. This needs to be in your working directory. So it's not in my working directory right now. We'll take a look at some of these questions maybe. Write the code knitted. Write a command that prints out the following. Which row has the highest? Add a column to movies ratio of the box office. Create a subset. We've already done all this today. I think it can be due on Monday. How does this assignment look to everybody? Like as you look through this, I know it's like 300 lines, but we've already made it out of the 300 lines. Yeah, we got this. We're halfway through it. We're halfway through this. And so what questions do you guys have right now? We've done half the assignment right now. If you are not getting this to load, this needs to be in your it needs to be in your working directory. So make sure you have your working directory set. I'll go here and set mine real quick. Go here, set working directory. Session. Set working directory. Choose directory. Okay. We'll go. Let's set the working directory and let's try to run it now. It should run because I should have my working directory. There we go. There we go. We got it working. So it wants us to, this is where people usually make a mistake on this one, is it wants us to, for each of these, print to the screen the results running the median of the requested. So this is where people make a mistake, run the median of the requested elements of box. So watch this. Here's a way to do this assignment and be able to read it at all times. Insert chunk. So median of all elements. Done. Take your pick. I will do 2 of these right now. Take your pick. I will do 2 of these right now. I will do 2 of them right now. What do we want? Take your pick. Let me answer a few more questions. You guys giving me some easy ones to do. What do you want? G and F. Let's do it. The 1028 through this element, including use a shortcut. Cool. This one. There we go. That should be it right there. Oh, wait. Wait. What did I do wrong? This element through this element, including elements. Anyway, through this. Let me take a look. What did I do wrong? Oh my gosh. Oh, BAS. Haha. There we go. There we go. So I did BAS. It was box. It's like, what did I do wrong? You always run your code. Look at what you get. So that's right there. All but the elements here through this. So all but those elements. That should be good. So we should just be able to go, you know what we could do? Could call this. Call it SEQ. What are you doing today, R? Why are you so mad? I don't know why I was being weird. And then we should be able to just go There you go. It's no longer answer this one, but... And then... Wait a minute. Oh, that's H. All but those elements. I think that's got it. Control Alt. Yeah, I should use that. That one I've heard a lot. That one I need to remember. I need to make a video like 5R shortcuts you need to know, like a 5R studio shortcuts you need to know. Like I should make that video. Like inserting a chunk is very important. I just need to make, or I can make 3R shortcuts you need to know. Like inserting a chunk. Or under help. Oh, where's it? It's under help where? Where's it under the help? I mean, there's so many things to learn. It's so awesome. Where is it? Like, where do I go under help? Like shortcuts? It won't tell me. It won't tell me, Andrew. Top 5 shortcuts with red arrow on the thumbnail. Cheat sheet at the top. Oh, wait, where? You might tell me where to click. Help next to tools. I'm lost, Andrew. Very top. Oh, okay. Oh. Whoa. Holy mackerel. I'm going to memorize all of these today. Memorize every one of these. But I bet you they don't tell you the one I know. The super secret one. Do they tell you... You see, I have to remember it. Do they tell you the shortcut that I had to look up? The shortcut to do the following. Do they tell you the... I think it's Alt-Shift. Yep. Do they tell you Alt-Shift, which allows you to write things on multiple lines? So if you hold down Alt-Shift, you'll trace down lines, and it's not doing it now. Trace down lines. Oof. Or is it Control-Shift? Go here. I lost my super secret code. It worked. I did it yesterday. Was it Alt-Shift? Maybe my R is just being weird today because I swear this works. The file edit code view plot session. Awesome. File edit code. I am lost. Keyboard shortcut help. So many things. What was it? It was Control Alt I. Split lines. Searching. I'll have to look at this. Whoops. I don't know why my hour's not doing the thing. But that, if you guys notice, this assignment is not so bad. So, Q4. Oh, that's for the work. I was doing the work elsewhere. Write the code. The object, the class. The classes are the first 4 columns. I know. You know what we might be able to do? I'm going to do a code right here on this one. So we got the movie database right here, which I think is loaded up. Okay, we got the movie database. And I think we can do the following. I think we can do... So if we do class of this, which I'm literally answering these questions now. There, it's a data frame. But I think we can do apply. Rows and columns. 2. No. Oh, and then... Yeah, and then we can do this. Fun equals... There we go. There is the class of the first 4 columns of the movie dataset using the apply function. So the apply applies a function over rows or columns. So apply is a really cool function. Just dropping some hints right now. Apply does a function over the rows of the columns. So if you were to do, like, let's say here, apply on survey 10 and 1, it would do it on every row. If you do it on 2, it does on every column. So right now I'm going to do a summary of every column. Do I need to put, yep, there it is. Here's a summary of every column. And it's a bit of a mess if you look at it, the way it printed to the screen. But that's a summary of every column. And we probably can't do a summary of every row. Oh, you can? That's even more of a mess. You could try to do a sum, but there's non-numeric stuff, so I think it should get mad at that. Yeah, it's getting mad. It might be able to do it on some columns. No, but it should be able to do it on, like, the second column. No, it's getting mad because of characters in there. So it's saying there's characters, you can't run this. Yeah. But I could go here and go to survey 10, column 3 and run it. And that's the sum of weights. So, and I gotta practice. Control Alt I, boom. Chunk inserted. Insert chunk. Control Alt I, Control Z back. Uninsert that chunk. But apply is really cool. There's S apply, T apply. For like S is like smart apply, T is table apply, L apply is list apply. The apply function is really awesome. But this will be due Monday night. Is anyone pretty far in this? I'll probably head off here in a moment. Who here is pretty far in this assignment? Feels like they've got a good start on it. Like, you could get it done today. Almost done. Yep. That's what we like to see. Not too hard. I'll head off here in a moment. I'll be answering questions. We'll do more work. But that's got it for today. Great job, Andrew. Andrew, you get the voice. I like hearing it too.
Good job, Andrew. You guys are all welcome.
Good job. I like doing the...
Do the crazy voices here. We'll
go to echo voice. Echo. Just having some fun. People say they like radio voice. I don't know why. I don't know why people like radio voice. I could give radio voice an echo. Here's echo radio voice. Sounds weird. I have these toys, we can play with them. Right here. Test 1 2 1 2. That didn't do it. Well, that's got it for the day, everybody. We're back here in 1987, and today we're signing off. So I will see everybody on Monday. Be working on your assignments. Have a great weekend. See you, Andrew. Bye.